Whenever we add whenever we add more complexity to something, it's a good idea just to check whether that's a good idea, right, to do this, because more complexity means more maintenance, more difficulty understanding what we've written. And yes, you can do this. And in fact, what someone has done is, I'm going to put this into the chat, um, is they've done exactly that. So this is a Stack Overflow discussion about how you could do that. And if you proceed to the top answer there, you will see that what they've done in this case is they have a function which effectively is used, or two functions, I think, that is effectively used to populate a variable. And that variable is then passed to PyTest mark parameterized. Okay, if I share my screen, that's probably the best way to go. Okay, right. Okay, does that look clear to everybody? Can you see that? Yeah. All right. So as we can see here, what's happened is they've written a function which does something. It doesn't matter particularly what it is. But then what they've done is they have a variable. Let's just pick this one, for instance, which then calls this function and populates this variable with the contents of whatever's being returned from that function. And then they're passing that into the PyTest mark parameterized thing here, right? And in this case, what they're doing is they're doing that for both of their arguments that are going into this test function. Okay, so this means that what you can do is you can populate these entries for the parameterization dynamically when the test script is run, which could be useful for certain use cases. But again, what we're doing is we're actually adding complexity here, and it's something we need to maintain. It makes our tests a little more complex to reason about. There is a slightly more appropriate way to do this, which is using a tool, a library in Python, which you can install called Hypothesis. And Hypothesis aims to do this in a way that's a little bit more structured. Okay, so basically with Hypothesis, it creates dynamic entries for parameterization for your test functions. It does it in a slightly different way. And what you do is you describe your data space, your input data space for your test functions. So if it was I don't know, a range of positive integers, right? It would basically create these dynamically when you run your tests. It decides what your test cases are going to be. You're delegating it the authority to do that. But the really cool thing is, what it does is it creates these test cases based on analyzing that data space. So it creates test cases that within the internal sort of data space that we want to test. So if it was positive integers, it would create ones like 4, 6, 7, 100, 1,000. But it also creates edge cases as well, right? So it's going to create edge cases like 0, very large numbers, for you. And effectively what it's doing is it's testing your code with the entirety of that data space. And the really cool thing is, because of that, it's basically coming up with use test cases that could be very difficult to come up and reason about by ourselves. We're just saying this is the data space for this particular thing we want to test, and it goes away and does it for us. And that can be a useful way of doing this dynamically. So that gives you another option to pursue. I do hope that answers the requester's question there, something to explore there if that's of interest. Right, so I think what I'm going to do now is I'm going to go on to continuous integration for about the next, well, we're going to do this perhaps maybe for the next 20 minutes. So I've basically put my repo back to the state it was in before I did continuous integration. I'm going to go through the steps in a little more slowly, and we'll see how far we get. So feel free to let us know if you're running into any problems as we go, and we'll do what we can to help you out. So just to start, I just wanted to get an idea of who who would like to be able to get their continuous integration working. So if you give me a green tick for those that are interested in getting that working, we can keep tabs on who's interested in achieving that. Okay, because some of you will have done it yesterday, and some of you were able to hang around afterwards, and we were able to help you get that up and running. So I can see 3 of you are keen to do that. Okay, so I'll just go through this, and we'll see how far we get. Okay, right. So what we're going to do is we're effectively going to define our continuous integration workflow. Okay. So the first thing we need to do, and you may have already done this already, is to create a directory where we're going to put that continuous integration workflow. Okay. And the command you'd use to do that is within the spacewalks directory, which in this case is the same as my root directory for my repository, is to make dir mkdir minus p dot github /workflows. Okay, and that's going to create a directory called .github, and within that directory, it's going to create another directory called workflows. Okay, if I press return, okay, and I'll do ls minus a, and I have to do ls minus a because if I just do ls, you can see GitHub is here. This is the directory you've just created. If I just do ls, we won't see it because it's a hidden file because it starts with a dot. So if we do ls minus a, that will show us this directory has been created because it shows us all the files beginning with dot as well. Okay, all right. So if you've been able to do that, feel free to give us a green tick for those of you that wish to follow along. Or you may have done it already, of course. You may have done this yesterday. So whether you've done it yesterday or have just done that, just give us a green tick. Okay, brilliant. Right, so the next thing we're going to do, and this is a quicker way of doing what we did yesterday to create our workflow file, is use a command to create the file, right? An empty version of that file. So we're going to use the touch command to do that. And so within our GitHub /workflows directory, we're going to create a file called main.yml, and that's going to contain the workflow that we're going to add contents into that we're going to run on GitHub. Okay. So the question in the chat is, why do we need to make GitHub hidden, i.e. this new folder that we created with make -p? That's a fair question. Why does it need to be hidden? It's effectively a convention for where GitHub is going to look for that workflow. And in their infinite wisdom, that's the directory name they chose when they were making GitHub Actions available. So it's just what we need to call it. So it has a special place, right? It's a special place known by GitHub for where we will put our workflows and other things to do with how we configure GitHub. Does that answer your question? Let me know if you need any clarification on that. No problem. So yes, it's a special name there that we need to use, okay? If we put it anywhere else, it would not be found, it would not work. And indeed, I've made mistakes where I put my continuous integration workflows in another location, misspelling the workflows or the .github part of the directory, and it hasn't worked. Okay, so it's an important thing to make sure you get right. So I'm going to execute that command, and what that's going to do is it's going to create a file within that directory, and within VS Code, if you run VS Code and open your spacewalks, if you haven't already, you should then be able to click on that, and you will find that you will get an empty main.yaml. Okay, so if you've been able to get to that point, if you could give me a green tick, that would be absolutely interstellar. For those of you that wish to follow along, if you've been able to get to that point, I think that's probably all of you and more as well. Okay, good. Right, okay, so we've just checkpointed, we've got to this point. That's great. Now we're going to write our workflow. So what I'm going to do is I'm going to copy and paste the one I used yesterday, and I'll go through it step by step. Okay, but I'm going to make sure that you have enough time to fill this in, and please let me know if you need more time. Right. So this is the workflow that we were using that I created yesterday. So what I did is I effectively gave our workflow a name. Now in YAML, right, and YAML is basically the name of the format of this file. In YAML, basically YAML stands for yet another markup language. There's lots of different data format languages. This is basically a language for describing data, okay? And in this case, the data happens to be a workflow, all right? And data in a YAML file is specified with key and value pairs. So you have a key, like a field name or something like that, and then you have a value assigned to that key, right? So in this case, the key is name, the first one. We have a colon there, oops, and we have a value. In this case, the value is the name of our workflow. So name is CI, short for continuous integration. We could call that anything we wanted, right, in this particular case. So the other thing we need to specify is when this workflow is going to run, right? And we do that by specifying a value or values for on, okay? So it's going to run on these conditions. And the condition we want to say is push. Now, as we remember from using GitHub, when we push things to a repository, that's an action we do. We do git push, it pushes our commits up to the repository. So every time a push is done on this repository, right, Effectively, this workflow is going to run. Okay, so this is what we mean by continuous integration. Okay, so we want this to run every time a change happens to our repository. So in this case, every time we push a change, set of changes, this is what's going to run. Okay, and then what we do is we specify a number of jobs that will run when this continuous integration workflow is triggered. And we do that by specifying jobs and saying what each of those jobs are. Now, as it turns out, the only job we wish to run is one that's going to do a build and test, right? That's all it's going to do, right? We could have a number of jobs specified, but we've only got one, okay? And you'll notice that we're using indentation similarly to how we would in Python to indicate that that's part of this list of jobs, okay? So indenting by 2, we could indent by 4 if we wanted, but I'm just using a convention of 2 because that seems to be the accepted convention to basically indicate that this is our first job. All right. Now, within build and test, we then specify a number of other things here. Okay. So the first thing we specify is what it's going to run on. Okay. And in this case, what I'm specifying is that this is going to run on an Ubuntu operating system, the latest version of that operating system. So when this workflow is triggered, what's going to happen is in the GitHub cloud somewhere, right? There's going to be a server that's going to start up and effectively be an Ubuntu-based Linux server, right? So it's basically like, you can think of it as just like a virtual machine in a way, right? If you've ever used one of those. So basically, a version of Ubuntu is going to pop up somewhere and it's going to have pretty much nothing installed on it. Okay, and that's where our build and test is going to run. This workflow will run on that virtual machine somewhere in GitHub land. Okay. Okay. All right. So now we've done that, we need to specify the steps that are going to run for each of the things that we want to happen within this workflow. Okay. And we do that using this. So you'll notice we're using a slightly different way of specifying this. Okay, and this effectively is a list. Okay, think of it as a list, an ordered list of steps. Okay, this is an ordered list of steps. The first step we have is one that's going to check out our repository. And we specify the step using this notation, which specifies that it's a list. So the minus there is specifying this a list. And the first thing we're going to specify is that it has a name. This step has a name called checkout repository. And that could be anything we want. We could call that anything we like. It's what's going to appear in the logs when we go back and have a look at what's happened with this workflow run. And we're going to say it's going to use an action. Now, GitHub Actions, unsurprisingly, perhaps contains a number of actions that we could use. And these are basically built in, you can think of them as built-in functions. And the first of these functions we're going to use is checkout. So when this virtual machine first starts, the first thing it's going to do is check out the repository in which this workflow is contained. Okay, so basically GitHub Actions gets hold of this workflow. First thing it sees in this is I need to check out the repository. So it checks out the repository onto the machine, okay, in its entirety. All right. You'll also notice it has this little thing here at version 4, and each of these actions sometimes gets revised. There are different versions of these actions, and you can specify which version of the action we wish to run. In this case, I'm going to specify version 4. There can be later versions. You can go to the marketplace in GitHub and find out what these versions are, okay, for these things, but we're going to use version 4. Now, the next step we're going to do is to set up Python. Okay, and again, we give it a name, anything we want. And in this case, we use a slightly different action, which is one to set up Python. So we're basically telling it that the machine should have Python installed. Okay, and we can pass a variable into that, which is the version of Python that we want. And in this case, we're going to say Python version 3.12. All right, and that's the version that we're going to use. So this machine's going to have the repository checked out. It's going to have Python available for us to use, which we're obviously going to need if we want to run our PyTest automated tests. Okay. Right. Feel free to ask any questions, shout them out if any of this is unclear, or if you're interested in a particular thing, just feel free to let us know in the chat or raise your hand or shout out. Okay. Particularly if anything's unclear. Now, the next step, now we've got all that sorted out, is to install our Python dependency. So this is very much like how we might do this on our own machines, all right? Where we would run Python -pip install, and then -r requirements.txt. You may recall this contains all of our dependencies, all our package dependencies for our project. So basically, we need to install that. And the way we do that is by using what's known as a run action, well, a run command, I suppose, right? Now, basically, we can have as many of these commands here as we want to. We can have another command here, whatever that might be, right? And in order to be able to do that, we have this little bit of syntax sugar, which is like the bar, okay? And the bar you might find on your keyboard in the bottom left, depending on where you are. If it's on a Mac, you might find it's in a slightly different place. On a Linux, it might again be a slightly different place. But basically what this means is we can then run multiple commands if we wish. And it seems to be convention from what I've seen that nearly every time this run command is used, you use the bar just in case you need to insert another command. Because if you forget to put the bar in, then it won't run, right? It's a little bit annoying. So this basically means we can basically write multiple commands on a single command on each line. Okay, so that goes ahead and that will install our requirements onto this virtual machine for Python packages. And then we have another last one, which is test with PyTest. Again, we can call this anything we like, with another run, which is running PyTest with our code coverage. Can you add comments into YAML? And the answer is yes, you can. And that can be a good idea, particularly if anything's unclear. So I don't know, perhaps we could have, let's see, hang on, I'm just going to check something. Right, so what we can do is we can say something like perhaps here we could say testing on 3.12 because that's uh, a platform requirement or something for our users, right? Perhaps that's something we're being very clear here. So yeah, basically we could put it in comments wherever we like into this in that kind of manner. I'll leave that comment there. Okay, so this is basically where we are, just like in Python. In this particular case, yes, it is just like Python. The other thing that's really useful to know is that when you're using YAML does tend to crop up from time to time, particularly in configuration files for various pieces of software and infrastructure. Okay, so actually knowing YAML and actually just knowing how to build continuous integration workflow in YAML can give you a head start in knowing how to format these files so they don't seem completely alien to you the next time you come across it. Right, so if everybody has been able to get to that point, feel free to, and I've typed this in and has a document that looks like this, feel free to give us a green tick. If you go to the shared document for yesterday, you will see there's a workflow YAML file that you can copy and paste. If you prefer, you can just copy and paste that into main.yaml instead. So yes, green ticks if you've been able to get to that point. And of course, if you have any questions or problems, please feel free to let us know. Right. Okay. So that's looking pretty good, I think. But yes, again, any problems, please let us know. Right. So now we have that. The thing we need to do, which is actually quite handy, in a way, is we just need to be able to. I'm going to create a terminal here. So if you open a terminal, is now add this file that we've created into GitHub. Okay, so I'm going to do that right now. Feel free to do this along with me. So I'm going to do git add.github /workflows and main. I'm going to use autocomplete there by pressing tab just to finish that off because it's a little bit easier. So add that in. And then what we do is we specify a commit message. So I'm going to say add CI workflow. Perhaps I should be more descriptive. CI for tests or something like that. Right. Okay, so if anyone sees this later on, they'll see that this is what this was for. It's always good to add a little bit of meaning in there. Be specific if you can, without being too verbose in your commit messages. So we now see that we've done that. Okay. Now all we do is we push it to our git push origin main like that, as we have done before, as you would commit any other file. All right, so we go ahead and do that. Now, let's see if everyone's been able, let me know when you've been able to type in those commands and you've been successfully able to commit that file and push it to your GitHub repository. Okay, you may have done this yesterday and got to this point already. But if you have been able to do that, just let us know. I'll give you a minute just to do that. Okay. So yeah, as before, we just add that file to GitHub to tell it that we want to stage that out. We then commit it, and then we push it. git push origin main. Okay, so I think everyone's there. Okay, I've seen some hands, thumbs up come up every so often as well. So I think that's probably it. Now we get to hopefully, if we've typed it incorrectly, we get to see some magic happen, right? So what we need to do now is we need to go over to our repository on GitHub itself. All right. And I'm just going to refresh this page. It's already run, of course it has. So if you go to your repository, you should see either a green tick or you should see an orange dot just here if you go to the main page of your repository. The orange dot means it's pending. If you hover over it, it should say pending. You may see a red cross, which means perhaps we've got a typo in our workflow or somewhere else, or you may see a green tick. Okay, so what I'd like you to do is let me know if you see a green tick or a red cross when it appears. All right. So if you see a red cross, please let us know that you see a red cross by indicating red cross in your reaction. If you see a green tick, please give us a green tick. So someone has an issue. Right. Okay. So, right, Stephen, I see that you've had an issue with that. So, what seems to be the problem? I guess you probably don't know at this point, but this will be a learning experience. So
Um, because I missed the this part yesterday, so I did it on my own and followed what you've the code in the guide. So I can see that the difference there is there's a matrix. There's a list of Ubuntu macOS involved. So I don't
so
know if I should use this one or should use the code that you have. So that's why I was
okay.
gonna
So
ask later actually.
right. So I'm getting some feedback there. So I'm getting some feedback there. So if you can mute the microphone.
Sorry.
Okay. Thank you. Right. Okay. Thank you. Right, thank you. So I think what you've done there is you've gone on to the more advanced build matrices one. Okay, all right. So that's
Yeah,
probably right. So yeah, okay. So I think that's a good question. We'll come to that one in a minute. But for the basic workflow that we've just done, I think what we'll do is we'll deal with that just now and come on to your question in a moment. Is that okay?
yeah. So I'll
Okay.
just wait for you to. Should I? So I will stick with the code that I have now and then come back to you.
Yes.
Yeah,
That's absolutely
yeah.
fine. We'll have a look at that in a moment. Okay, so the way that you can find out what has happened is one of two ways. You can click on this, right? And hopefully you'll see it's green and it will say successful and how long it took. It could be that it will still be pending and that will say it's pending, it's orange and it's still running. You'll see a little circly thing here indicating it's running, or you'll see a green, yeah, you'll see a red cross saying it's failed. But in any event, what you can do is you can click on details, even when it's running, right? That's one way to get to this. The other way is to go to Actions and then click on the one that's at the top. That's the most recent run. Again, even as it's running. And then you can click on, you may recall we can specify multiple jobs. So this is a list, this is a summary of this workflow run. And you can see we have only one job, which is build and test. We can click on that. And then we can see a summary of all of the actions that happened. Now, you may remember some of these actions we defined in the name fields for each of the steps, right? Check out repository, set up Python, install Python dependencies, test for PyTest, etc., so on and so forth. Okay, so if you have a problem in this, then you should see a red X here, and it'll open up and you'll be able to see the problem. Okay, but in any event, you can drill down on any of these, and you can see what it's done. Okay, so we can see that it's doing various things here to set up Python for us. That looks like it's fine. Installing Python dependencies, that's going to be a list of all the things it's installed, which is again what you would expect. And then if we look at test with PyTest, we can then see that we have a log here which says basically the output of running that command. Okay, and we can see all these things that have happened. We see the 5 tests have run. We can see the coverage report here. So that's really handy. And this is going to happen every single time we make pushes to our repository. Okay. Right. So we have a question there, which I think we've covered, and Philly has too. Thank you, Philly. So does the red cross appear if the tests within a correct workflow fail? Yes, if the tests fail, you'll get a red cross, Philly says. That is correct. And indeed, if the tests fail or any part of this workflow fails, you will get a red cross. So basically, anything where it exits from one of these steps with an error will basically give you a red cross indicating the workflow has failed. Okay. Yeah, that's a good distinction to make. Okay, because the testing itself will have concluded, but if it had failed, it's also going to show us that has failed. Okay. So yeah, so that's where we got to with the basic workflow that we wrote. I hope that was useful. If you have any other questions, please feel free to let us know. Okay, you can put them into chat or yeah, just shout them out. I think what we'll move on to, I'll come back to that in a minute if you do have any questions. But also, I'm going to have a look at what Stephen was doing. So I think he went on to the more advanced section there a bit later on. We'll have a quick look at what Stephen did. Right. So, Stephen, would you like to let us know what the problem was? If you go to the log, can you see what the problem was? Does it say where it failed? Oh, Stephen, are you there? You might need to unmute.
Yes. So I went to the log and I think it has a green tick for those with macOS because I'm running on Mac.
Okay.
For Ubuntu it worked, but for Windows there is like a exclamation mark, and there is an
Mm.
X for Python 13 or something. So
Interesting. Okay. All right. So that's interesting. I run this workflow myself day before yesterday, and it did seem to work across all. So I'm wondering if there's something there that typically this is usually I usually find this is caused by something in my requirements.txt, which is platform specific. So if you look at your requirements.txt, you should find it only contains high level requirements, but sometimes when you do a freeze, it can capture low-level packages that are installed to cater for a particular operating system. And sometimes that means it fails on particularly Windows, I find. And sometimes, yeah, that can cause issues.
mm,
So that could be a place to start. What we could do very quickly is just have a look at your screen if you wish to share, and we can just check it out. Perhaps there's something
yep,
that we can see. So I'm going to stop sharing. We'll just have a quick look at what you're doing there, and see if we're able to find the problem.
sure. Share screen. Yep. I went to the requirements. Can you?
Right. So
Yep.
right. So are you able to share your screen at all?
Yeah. Can you see my screen?
No, I can't anyway. I think there's something wrong with my Zoom client. I'm not quite
We
sure why.
can actually. Yeah,
That's
we can
that
see.
that's interesting. I might need to go out and come back in again, annoyingly. My Zoom window has completely disappeared and I cannot access it. I don't know what's happening here. So apologies for that. I'm just going to quickly come out and come back in again. I don't think I'm going to make, yeah, so Philly's the host. So yeah, that's no problem. I'm just going to come back.
Okay.
Right. So apologies for that. That was a bit annoying. I'm not quite sure why that happened. Okay. All right. So let's have a look. So I see you've got your requirements.txt. That all looks quite reasonable. So the other thing we can do to diagnose the problem, and this is a learning experience for everyone, would be to go and have a look in detail at your workflow report. So let's have a look at that. So
Okay.
if you go to your web browser and have a look at the actions report for running the workflow, right? Okay, so if you go to build and test, so it looks like it bombed out on Mac OS. That's interesting. Mac OS using Python 3.13. That is interesting. So so that one's got Okay, I don't think it's managed to do that one. So the red cross one, if you click on that, that's the one it failed at. The ones with an exclamation mark and a clear circle basically are not the
Yeah.
ones that will run. Okay, so yeah, is it loading for you? Oh, it looks like it
Yep.
is. Good. Okay, so it looks like a Python dependencies issue. This is usually where the problem is. Right.
Mm.
Okay. Whoa. Okay. So if you scroll up a bit, it looks like I had a problem installing NumPy for this particular version of Mac OS. So if you keep scrolling up, so this is interesting, right, in a way, because this is telling us that if we were to try and do this on Mac OS, other people may suffer from this issue. So, right. So if you keep scrolling up, keep going all the way up. Crikey, that's a big one. You can see, so when an error happens, what happens is it gives you a breakdown of everything that happened, right? The entire output. Um, so here we go. Right, stop there, down a bit. I think there was an error that, oh, uh, I think there's a bit of a delay. Um, yeah, so if you scroll down a bit, there was something I saw there. Keep going down. Keep scrolling down. Stop. Just there. Up a bit. Okay, this is taking a little bit of time. So here we go. So it says a warning. Project specifies a minimum meson version of 1299, but uses features which were added in a newer version. So it looks like there's been some kind of lower level dependency conflict there in what it's trying to do. Okay, so it could be that there's a problem with our requirements.txt for this particular version of Python on Mac OS, that it's having problem resolving that when it's trying to deploy our Python dependencies. And so in this case, this tells us something. And what we would do is we'd go and investigate this issue, all right, and see if we can resolve what that problem was. And it looks like, interestingly, it worked on Mac OS with Python 3.11 and with 3.12. You can see green ticks there on Mac OS latest, just above that. But it's only Python 3.13 that had the failure, right? Now, if you look at the versions of Python that are currently available, I think the latest is indeed 3.13, right? And what this tells us is
Yeah.
it could well be, okay, so it's actually released just before this. This could tell us that our project in this particular case isn't quite ready for Python 3.13. So that's telling us something interesting, right? It's telling us it works on 3.11, 3.12. So we'd have to verify whether it's a problem with our requirements or whether, our code is not going to work on this particular version of Python for whatever reason. Okay. So usually at this point, I'd get hold of a Mac OS laptop from somebody and just try and deploy it and see if I could get it working myself. And if I could, then that's probably something to do with my build, right? It's difficult to tell, right? So, but this is an interesting way of diagnosing these kinds of issues, and this is exactly the kind of reason that we use continuous integration. It gives us something for free that would otherwise take time. And indeed, the follow-on from what we've looked at so far, which Stephen sort of looked ahead and read and followed through, which you can go to in the materials, is what he's done is to take the next step, right? And I won't go through this because we do not have time. But if you follow along from build matrices here, right, it basically allows you to expand the amount of operating systems and the Python versions that you are testing against. So I'm just going to, if I could share my screen, I'll be able to show you that. Right. Thank you, Stephen. Right. So I hope that was useful for you. At least it gives you a place to start. Right. So here, right, in the material, you will see that you can replace your workflow with this slightly more complex version. So instead of having runs on, which you may recall was here, we've added it with what's known as a build strategy, right? And we supply a matrix to this build strategy, which is the operating systems that we wish to test against, in this case, Ubuntu, Mac OS, and Windows, the latest version of those, and the number of Python versions, right? 3.11, 3.12, 3.13. And you can see we use a very similar format to Python in specifying a list of each of those. And what will happen is this workflow will run basically across every permutation, every single permutation of this and this. It gives us the product of that. So Ubuntu latest will be tested on 3.1, 1.2, 1.3, same for macOS, same for Windows. So in essence, what we'll get is 3 times 3 workflow runs, which in this case will be 9. And what we do to reference each of these different things for each iteration of that run, each permutation, is we've referenced each of these as a variable. Okay, so in this case, matrix.os and matrix.python version. So here we're saying runs on matrix OS. So for a particular run, it'll be something like Ubuntu latest, or it could be macOS latest, whatever. And then further on down, what we do is we then substitute the version of Python with that variable instead, right? So we say matrix.python version here. So we can clearly see what we're supposed to be testing against in the name, but also for the Python version here that needs to be set up on the machine. So we can see here that what we're doing is basic variable substitution, if you like, for each of these different parameters for a particular run. So that means that we can test across all of these, and we can indeed create as many of these as we wanted, right? These variables for different parts of a workflow to test different aspects of it if we wish to do so, okay? And when you do this, it means that you get every single push, you'll get 9 runs across all these operating systems and Python versions, and you get that basically for free. Right. And it's really handy just having something like this in there because it means you're automatically testing on all these different versions. And you can say with some degree of confidence that your unit tests are able to run across all of these and that, hey, you know, this piece of code, should run on your machine with this operating system and this particular Python version. Okay. Right. I see I have a hand there. So yes, what's your question?
So my question would be that what are these matrices? You see the term matrix, and I'm not sure why this is a matrix. I mean, what's the context, please?
Okay, all right. So what it's producing is a matrix from all the permutations of these particular variables. Okay, so effectively, you're going to get a 3 by 3 matrix, right, of these particular variables every single instance. So Ubuntu latest, you're going to have entries for 3.1.1, 3.1.2, and 3.1.3. You'll have an entry on the next row, if you like, for macOS latest for 3.1.2, 3.1.2, and 3.1.3. Then you'll have another entry in this matrix, in this row, as a row perhaps, for Windows also with each of these, okay, if that makes sense. So basically you're building a matrix of all the jobs you wish to run, where every cell in that matrix is a single permutation of these particular variables, right? And each cell represents a job that will run. So, okay, so on the x-axis of our matrix, perhaps, right, you'd have this, and on the vertical axis, you could have that. If that makes sense. You're populating that matrix of 9 cells in a 3 by 3 matrix. So it's basically filling that space of where every single cell is going to be a job that will run, if that makes sense.
Yeah.
And then from each of those cells, we then pull out the variable instances for each of those permutations and put them into our run of this workflow. Yeah, does that make sense?
Yeah, that's perfect. Thank you.
Clarifies a bit. Yeah, that's a good question. It's a little tricky to get your head around. Okay, so I think that's all I wanted to say for this. But if you have any other questions, yeah, feel free to ask away. I'm just going to check the chat because I haven't done that for a while. Thanks, Philly. Thanks to link to the materials about build matrices. Feel free to follow along with that in your own time. That's good. People have been debugging. That's good to see that people have been debugging as well there, YAML and getting it to work. So that's great. Okay, all right. I think with that, I'm going to stop. But yeah, feel free to keep adding questions in the chat if you like. I'm going to pass over to Aman for now. He's going to take over. All right. Thanks, everybody.
Thanks a lot, Steve. Hi, folks. Thanks to everyone who has sort of followed along, and I think we've covered a lot of ground over the past 3 days. So the major sort of episodes for today that we were planning to cover are software documentation and then collaboration and publishing your code. But before we get on to the part about software documentation and basically we look at management, collaboration, or like sort of archiving and publishing, We thought it might be a good idea to just check with the room if there are any general doubts that you might have from the past 3 days, or is there a place where people might feel stuck? So I know in the morning we did cover the continuous integration again because that was kind of like a quick whiz tour yesterday, and it is an advanced topic to be fair. I mean, I'm surprised that we were talking about matrices. I don't think I have used many matrices while doing CI, or like they come up a lot. But yeah, uh, just yeah, an open question to the room about say whatever we've covered so far with code readability, the structure, the testing, the correctness. What questions do you have? And if there are any places in particular that you feel stuck, feel free to enter your responses at the end of the document or raise your hands or in the chat, and we'll try to sort of, yeah, take it from there.
So I have a question. So maybe a silly question. So let's say we have this, we have now worked through this YAML file, and let's say I have a different repository. Can I use this as a starting point to explore and start using?
Absolutely. In fact, that's why I think we started with a more generic YAML file. And again, the YAML syntax remains the same, and the GitHub action syntax remains the same, where whenever we're doing the sort of GitHub runners, a lot of the Python testing you might see would be very similar. So you can alter some variables here and there. So it can be, say, like we looked at which OS you're using, which version of Python you're using, or what kind of testing you're doing. And yeah, you can have like many kinds of actions, but this is, I think, a great place to sort of initiate sort of, yeah, continuous integration on other projects that you might have.
Okay. Yes. Thank you. Thanks very much.
Thank you. Yeah, I'll wait a couple more minutes if there are any other questions. Again, this does not have to be just about continuous integration. Uh, any other general questions? If not, yeah, I guess we could do green text. So if people are happy for us to sort of continue with software documentation, could you put a green tech? Okay, I see quite a few green ticks coming in. Again, as Steve said as well, at any point, if you feel that, yeah, there's something that is unclear or you need more clarification on that, please do tell us, and we'll try our best to sort of sort that out and then move. Okay, I see quite a few green ticks, so I think we can start with software documentation. Let me just get my tabs up. All right. Is my screen visible to everyone?
Yes.
Okay, perfect. All right, so we'll be talking about software documentation today. And documentation, as some folks might be aware of, or again, we have come across documentation while learning the course itself, while looking at the other materials, or while looking at different sort of features, is an important part of just sort of the coding process, the software development lifecycle, where it helps make our software better. It helps us make our research more reproducible. Uh, one, I think, yeah, sort of common way to frame this is that when we look at software documentation, uh, as a user, say, if I'm trying to use PyTest and I just sort of access the PyTest package and I have the code base, but I have no instructions on, okay, what commands to run or how does PyTest actually work? The question I would have is how do I actually use this, or how do I go about this? How do I run the different tests, or how do I sort of change the commands with whatever package I'm using. And as a developer on the other side, and again, I think you might see that even with the code that we've written so far, that if you look at it like say 2 months later, and there is sort of no documentation, like we were talking earlier about comments or like descriptive uh, variable names, you might just question, okay, why did I choose this variable name, or why did I have this code here, or why did I sort of make this choice? So for both those things, I think from the user end and from the developer end, uh, documentation can be quite helpful. So there are different levels of documentation as well, where we have the code level documentation, where we have the technical documentation. So whenever we were looking at the comments, so for example, here on line 15 and 16, we see two comments. One is just commented out, and the other is again just a general comment. Those are kind of just, yeah, those are comments that can be also used as documentation. So on the top, we can see we have the URL for the data that we're using. And again, that is helpful while, say, you're looking at a code base, or you've written something and you want that information within the code base. So there are quite a few different levels of documentation. You can get quite deep into it. There are like guides, there are tutorials, there is just general documentation like this. But we'll look at a few major things. And then again, as we looked at CI or a few of the concepts, this can be extended into sort of a lot of in-depth documentation if you choose to sort of do that for a project. So when we look at sort of the FAIR practices, which are findable, accessible, interoperable, and reusable, we look at coding conventions and documentation, and we see that it helps in accessibility, interoperability, and reusability uh, majorly, and also helps with findability. But again, the findability is not directly linked. Uh, I'm not entirely sure why we have an asterisk there. If one of the co-instructors might know, but yeah, like in terms of reproducibility, in terms of looking at fair software or just good software practices in general, documentation is quite helpful because again, it is helping us navigate any tool, any piece of software, uh, or understand it without actually, say, even knowing what the code is like or having to get into the depth of it. So, okay, yeah. So when we look at the reasons, it's like, yeah, documentation provides additional searchable content and helps users access our code. It helps developers to understand and make sense of our code. And then again, documentation answers question users. Uh, the other developers and even ourselves, we may have about the code, say, in the future, or say a user comes in and they have a question about something in your project, but there is, say, a Q&A section, or there is something addressing that particular problem. So sometimes we do that with bugs, for example. That's a very, very common, very fast moving way to document, where you might see, oh, this current version of Python does not support XYZ major package. So if that is, say, the case, you would usually see that they would put that out on like the main release, and they will say that, okay, these are the sort of things that this might not be compatible with, or these are things to keep in mind. So again, there are lots and lots of users, just from sort of simple telling what the code does. Sometimes it's also what the code not does, or who is it for, or what sort of is the way to install it, or how do you develop it. So again, as I said, there are quite a few ways to do it. If I just go to the material for a bit, uh, and yeah, I'll just sort of quickly go over it. This can become like a lot of theory, so I'll try to sort of explain the major concepts, and then we can try to just sort of add files and get our hands on with documentation. So as we were talking about, there is technical documentation, so you can have tutorials on how do you sort of uh, build through the exercises and how to use some code, or some how-to guides, which are just specifically, okay, how do you do X with Y? And then there's reference. So reference documentation is more like when you have the code signature of a function, for example. So it tells you which types of variables this function accepts, or how many arguments it is accepting, or what are the different attributes that you can add to it. An explanation is again the general conceptual discussion of the code itself. That's within the code or about the code. But then when we move one sort of step further, it one level higher takes us to project level documentation. And again, with project level documentation, there are quite a few things that we can look at. So this you might have come across when you're looking at uh, GitHub projects that are like pre-existing or like things that we've already been looking at. So there's the README, there's the contributing, there's the code of conduct, and we'll get into a few of these. A few of these you might already be familiar with. So again, README is giving us the overview of the projects. This is the landing page that we have on GitHub, where it gives us all the information about the project. Then contributing is how do you contribute to this project? So if I'm inviting someone to say add a particular feature, or like in general I'm opening up my project to contributions, it would be a guide on how do you make those contributions useful. Code of conduct, so like we have a code of conduct say for this course. Software projects can also be communities, or software projects also involve a lot of interactions between people. So a lot of projects have code of conducts on how you're expected to sort of generally interact with the project and the people involved with it. And then licensing, again, it defines the legal terms of using and modifying the code. So a lot of what we have been looking at has been open source code, but within that, there are lots of separate sort of clauses, or lots of different types of licenses where some are more permissive, some are less permissive. And you can again kind of look at a varied approach to licensing as well. Citation is this is something new-ish, I would say, but citation is like now GitHub has the support for a file called the citation file format. And like we have citation for, say, a research paper or a journal article, we can also cite software now. And so if we use a CFF file, it gives us a citation in the format that can be just used like we're used to citations in general in research. And then authors is for like providing information about the authors. So these are a few different sort of uh, major tools that we use to sort of document the different parts of a project. Uh, just before I move on, I'd again open the floor for any questions. So, what questions do you have about, say, documentation in general? Like we'll get into the depth, but from an overview, do we have any questions? Okay, so I don't see anything yet. Now, just as an example, I thought that we could look at a couple of projects that we've been using in this sort of this week in this course. For example, this is the pandas repository on GitHub, and we've been using pandas to sort of do a lot of our uh, code runs, and a lot of the features that we're using within our code base are running on pandas. So if you look at this repository, I'll show what we were talking about. This might have a lot more things because it's a big project, which is very popular in the community, and it has a lot of uh, activity and a lot of users around it, and a lot of development that is continuous. So again, like we can see, there was a commit like 1 hour ago, so they are actively developing the project and actively sort of releasing new iterations. So if I just scroll past, these are all our sort of documents, the files of the project. And now this is the README that we were talking about. So a README is basically our entry to a project. So you can think of it as a landing page where you get the crucial information about what your project is about, what are the different sort of necessary information that you might need, or what are the sort of different sort of ways to interact. So here we see like a few badges, which is, oh, it's talking about the testing. So it tells us, oh, the unit tests are passing. So this might be something that they've implemented through the continuous integration, where there's the continuous integration running every time they push some code, and it checks whether the unit tests are passing. And if they fail, this badge would turn to fail, which again, the badges, uh, we'll see if we have some time, but I can always add information about the badges if folks are interested. These are kind of a nice way to have some live information on the top of the project. And then we have some code coverage as well. Then it gives us sort of links to the package where you can download it, and then just sort of general information that, okay, which license does it have? Which Slack do you go to sort of talk about the project, or uh, who supports this project? So NumFocus is the organization that is helping run Pandas. Now, again, it keeps going about what Pandas is, what the main features are. Then it talks about dependencies, how sort of you install it, and there is host documentation for Pandas as well. So if you look at this, this is the bit that I was talking about, that you can go into a lot of detail about documentation, where we have a whole website that is documenting Pandas. And these are just sort of the different uh, ways you can interact. So just how to get started. Then you have the user guide, the developer guide, and the API reference. So they have taken these 4 sections, but again, this is very in-depth. This is not always, again, needed for simple projects, but again, sometimes some projects require the different aspects of documentation, or different ways that someone might interact with the project. We will mostly look at GitHub level documentation and code level documentation. But yeah, this is an overall example. Then, as I mentioned, there's the code of conduct that they have on how you interact with the project, the contributing guideline on how you contribute, the license they're using, and they also have a security document which talks about the security of the project. On the other side, again, this is all very nested. So, like when we look at Citus repository, it gives us an APA and BibTeX. So that's the citation file. And again, a lot of information that we've been talking about. So all of this is visible in GitHub, and you can integrate your project into showing this information if it's relevant for the project itself. Okay, so that was kind of a very quick overview of the documentation that we're talking about. Now, what we can do is we can create a README, and we can start adding documentation about our project itself. So what we're planning to do is we'll go to our project repository, we'll go to the folder, and then we'll add a README file and then add some information about it. Okay, we have a question in the chat. How do they show the contents of the documents in a viewer window on the repository? Could you elaborate on that? Does that imply, like, how is it being rendered on GitHub? So, for example,
Yeah,
this
sorry, I was
is
just kind of wondering, because on the list we could see that the README and the license and everything was there, but then when you
yeah,
went lower down, it's like, oh, you can just see it without
yeah.
having to open the documents.
Yes, so that is basically the GitHub integration. So that is the feature of GitHub, that they have designed certain information where you use a keyword or you use certain sort of syntax, that they will render that document and show it in a readable format. So, for example, a README is in a markdown format. Now, when we look at the code itself, this is kind of the markdown, but GitHub uses the README as the sort of landing page, where if you have a file name readme.md, that will be the first thing that will show up. In fact, like a lot of these tabs, these didn't used to exist earlier. They have added these as features later, where they're using the code of conduct or the contributing and rendering it out of those files. Same for citation file format. So like now we have this integration where we can copy the citation in the sort of accurate format. But if you look at the citation CFF, this looks like a lot more like YAML, for example, or a lot more like just describing the markup language rather than a citation file format. But that is the GitHub integration that gives us this sort of little tab here that just we can copy the BibTeX or the APA, and we can view the citation file from here. But it's these are mostly GitHub features. They exist on other platforms as well. Uh, but if you just look at sort of your say VS Code instance, your folders, those would just sort of appear as the raw files themselves. Hope that helps.
Yeah, thank you.
Okay, so now what we'll do is we'll create the README file and then we'll add some information about the project. So if folks are familiar with the Markdown format that we've been using, I'll just sort of add the information to our notes document. And I think we can just copy paste, as in like there is not a lot of code along in this. This is just more or less information. So you can feel free to copy paste from here. Okay, let me just stop and reshare. All right. So we are in our uh, code folder and we're looking at all these different files. Now to create the README, what we'll do is this command we've used before, which is touch, which is used to create an empty file. And I'll say touch readme.md. And this now gives us a README file. Now we can see that even VS Codium is recognizing the README file. It's giving it the I symbol. And again, because it's a very popular standard format, a lot of different code editors, a lot of places recognize it as, oh, this is the place that you look at for information. And this is also like not just in software projects. You might see this with sometimes a piece of file you've downloaded, a zip you've downloaded, and when you unarchive it, it will have a readme.txt or readme.markdown, which is basically an invitation to that, yeah, to know anything about the piece of code or the piece of file, you read this file first, and this will give you the information. So let's first start with this. Now, from Spacebox, this is where we're adding our README. So again, I'm just adding it to the shared notes for folks to copy paste. And again, this is not like there is no absolute right or wrong here. You can edit this, you can make it your own, you can sort of just add the description that you'd like to or remove what you'd like to. Now we've added an overview of talking about, okay, this is what this project is about. This is what this project is doing. Now we can add a few features. Again, this is just Markdown that we can add. I think it's the selection that is for some reason messing it up for me. I'll read out. Okay, so yeah. And again, as is the standard with Markdown sort of syntax, where a single hash is the first level heading, and then two hashes are the subheading, and then you can go deeper and deeper with that, like we see in the CodeMD itself. And then we'll add a few prerequisites. So the prerequisites, we can see that, yeah, we'll give it a few of the major information about like which packages we're using to install and run, what all do you need, or what are the dependencies of this project. And again, we're giving the sort of link to the project and then talking about what version you're using or how we're using it. So we talk about NumPy, Matplotlib, PyTest, and Pandas, which are the four core sort of dependencies that we're using in this project. Now, I'll add all of this to my document as well. And I know we're like almost at the break, so I think we can sort of wrap up with the README. There's a mini exercise if people fancy doing it, where what we want to do is essentially extend the README of this project by adding installation instructions and a simple user example. So I would suggest that if folks want to do either or, I'll paste the exercise in the chat. So patient takes it in the chat, and I'll give folks about 5 minutes to sort of generally map it out. It does not again have to be quite detailed, or it does not have to be. There's not a lot of information that we want to sort of go into the depth of. That's not kind of the exercise here. This is just sort of more to understand on how readmes work or what their purpose is. Now, there is a question in the chat, which is any general principles on what content should be placed in a README versus other written documentation, example, wikis. I have seen several READMEs with way too much information at times. So this is kind of a tricky question, as in it's very subjective, I think. So I do agree with what you mean, where there are some READMEs with way too much information, or like some READMEs that are kind of doing all the heavy lifting of like all the documentation of the project. And you can make them shorter, but again, I think it depends on the scale of the project, who your users are, who is interacting with the project. So, and like what kind of information you find it essential. So sometimes again, READMEs are just sort of the say single developer that is wanting to document for themselves or for their colleagues, versus sometimes READMEs get affected by the community. So the community says that, okay, this is something that we want right on the README and not say within a hosted documentation. Now, I think a few general things that we saw with pandas might be sort of a good way to look at it. So if we look at the table of content, yeah, so it's talking about the main features, the dependencies, the installation, and then there's the license and background. I think from my understanding, it's like mostly about how do you get started with the project? What's the project about? uh, then the essential licensing and documentation of like, okay, this is the external information you might need. And then maybe something about how do you get help about this project? Who do you get in touch with? Some projects, say, for example, have the all contributors guide, which shows all the contributors of the project. So a lot of community focused projects want that all the contributors are on the first page mentioned. Uh, oh yeah, thanks, Philly. So the we do have the material which talks about what kind of stuff you should have in the README. So yeah, that is also kind of an exercise which are essential, what is good to have but optional. And if you are trying to say follow FAIR principles, then your priorities might differ. Where some projects want, say, a certain kind of README, which is very opinionated or very intentional in a certain way. And also, like, yeah, that's the same with badges. So some projects, I think, go overboard with badges where it's just sort of too much clutter, or some projects don't have enough information. But again, everyone has a different approach, and I think every project sort of takes its own way. Uh, but yeah, I will give folks like about 5 minutes, and if there are any other questions about READMEs, or if
Oh,
folks
just
want
a
to, yeah,
question, Aman.
yes, Stephen.
Yeah, I have a question. Uh, how do you add those, logos? Like the pandas has
Oh, the logos.
has like a
Yeah,
sort of
so
a
that's
branding.
again
So it's just
That's again markdown
or like
syntax. So
is
we
that
can we can look at the README and we can see how they've done it. So if you look at this, that's the source code for the image on top, where I mean they are using HTML here. I think these are HTML tags, right? Uh, just to check with Billy and Steve. But yeah,
I
basically
see.
depends on again what kind of files you're using. So I think Markdown and HTML and CSS work together, but depends on where you're rendering them. But here again, we're just using a picture source and we're giving it where to pick that image from, and then it renders it in the README when we
Mm,
look at the preview itself. Let's maybe look at mat.lib. I think yeah, a lot of the projects
I
follow
see.
very similar.
They've called it. Okay, thank you.
Yeah. So just on that note again, for example, we can see these are all the links for the badges that mat.lib has. So on the top, there are all the badges. And if you look at the code, this is how they have the badges link, which are again interactive links that render those badges live on GitHub. And for their image, so they have used the Markdown format instead of the HTML format, which again, this is mostly just sort of general syntax, universal syntax for Markdown that can sort of help you add different things. So if you want to add a table, if you want to add an image, or if you want to add a list, there are certain sort of ways to do things in Markdown. And yeah, you can kind of modify your README to look however you prefer. Okay, I'll give everyone a few minutes. And then I think we can take a short break. And just a recommendation, for example, when you're thinking about installation instructions or user example, you do not necessarily need to think of the perfect way. You can just think of what you did to sort of install uh, packages or get your project running, or how do you use the project itself? Because essentially, this is documentation from the developer on how does someone else install this. So you can talk about cloning, you can talk about the packages being installed or environment being created. And same for usage, you can talk about what are the commands people can give. Yeah, just to highlight what Gaurav mentioned in the chat, Control Shift V. So let me try Command Shift V. Oh no, that's doing paste for me. But this sort of icon, for me, it's oh, okay. It's weird. I think the shortcuts are conflicting, but basically this icon that we have in the corner, that gives us the preview. So this is basically the preview of what we've added. So if you're happy with the README, if you've extended it and understood sort of the essential aspects, if you could please give us a green tick, that'd be really helpful. Okay, I see a few green ticks. I think we can also take a break now. We've had like a intense morning session with the theoretical bits. Uh, but yeah, let's say we can be back at 10:35, a 15-minute break. Thank you. And if anyone has any questions about what we've discussed in this session or in general, please feel free to ask. We'll be hanging around. Okay. Hi, folks. As people are getting back from the break, if you could give us a green tech, please. All right. I think most people have got back. Can make a start. Okay, so we have looked at the README file so far. Now we'll look at a couple of other files, which we discussed initially. So that's the license file and the citation file. I'll give quick sort of overviews of both of these files. Again, as is with the README, these are kind of like standard files. So there might not be a lot of modification, or there might not be a lot of logical editing or coding here. It's mostly about how these standard formats exist and how we sort of use them in our projects. So we can have a quick look, and then I think it would be good to sort of look at dedicated documentation where we have certain packages that help us documenting our code in a more efficient manner, which I think would be quite helpful to look at. So I'll just share my screen again. Okay, hope my screen is visible and is big enough. Okay, so let's talk about licensing. Now, licensing, as again you might have come across before, is kind of the permission that we have to use any kind of software, or the permission that we want to uh, provide our software on, like the rules that on which how it could be used, or how it can be sort of downloaded, how it can be modified, all those different rules. When we sort of look at the legal language around it, it gives us the license file. Now, copywriting allows the creator of the work to state that they own the work that they've created, and it is automatically implied even if the creator does not explicitly assert it. Copyright of the work exists from the moment of the creation. A license is a legal document which sets down the terms under which the creator is releasing what they've created. So it's more for sort of the legal purposes, but also it helps people understand what sort of project that you have, what kind of license it has. In certain contexts, and I guess in modern contexts especially, it's not always honored. But again, say when we have public data sets, or when we have public code, and say there is this code archival tool, or if there is this kind of, I don't know, say if there is a tool that is using a lot of open source data on GitHub, it can sometimes go according to licenses, where it's like, okay, this code is using all MIT based projects for its database. Or like if we look at, say, LLMs, I mean, there it gets a little murky with what kind of licenses they're using. But a lot of open source sort of models, a lot of open source coding runs on certain licenses, and also implies that, oh, if you have this license, it might be used in this external project. But again, as a general practice, it's good to have a license, and it's also good to sort of check license permissions when using a project. Now, when we look at licenses, there are a few different tools. So we have the open source guide and chooselicense.com. Uh, Again, I'll paste the links in the chat. Now, this again is talking about what are the legal implications, or why you should have a license, on how these licenses work. Uh, and if you need to choose a license, this is chooselicense.com. There's a kind of
Can't hear. Is it just me?
Sorry, Aman, I think we've lost your audio. I want.
Hi, am I audible now?
Yes. Oh, we can hear you now.
That was a funny one because I think both my devices switched. So even if you turned on your mic and told me, I could not listen to it. But yeah, thank you. Where did you lose me? Was it on this page or the previous one?
You just mentioned chooselicense.com.
Okay,
That like literally just popped this page up. So
right.
probably
Yeah,
start from the explanation of what it is.
yeah. Okay, thanks, Philly. Sorry about that. Yeah, I think it might just be another device that it connected to. Uh, right. Okay. Going back to chooselicense.com, uh, this sort of website helps sort of simplify on how you could choose a license. So there is the different philosophies or the different ways. So if you want to work in a community, if you want it simple and permissive, or if again there are sort of licenses which are like more about sharing improvements, but then there is say license around, oh, my project is in software. So if you look at the content of this course, that is on CC BY, which is Creative Commons. So a lot of content and documentation uses Creative Commons, for example. There are quite a few different licenses with a lot of different philosophies, and you can look at kind of the more suitable ones. So, for example, the MIT license is short and to the point, and that is a popular code license that you might have come across, or even the GNU license, the GNU license, which again are two of the popular open licenses. And for content, it's usually the CC licenses that are quite popular for content. And again, if we look at this course or the material, this is all CC BY. Now, there is this additional chapter which talks about licensing. I'll just paste this in the chat. We don't have time to go into the depth of it, but again, if you're interested, you could go through this. This is a lot of the same information that we have on the other two websites. So choose a license and the open source guide, which again goes into the depth of why do you choose a license, how do you choose it, what are their sort of different kind of philosophies. And it talks about permissive, copyleft, copyright licenses, and then creative licenses. So essentially, we look at the licenses, we choose these uh, in a project at the highest level. So if you remember, while creating the repository itself, you can also add a license by default in GitHub, and that should also sort of create a license for you. Now, another way to add a license, what we can do is, since we already have a repository, we can go to a repository and look at the licenses in the repository and just add a file, which should give us a few options. Okay, let's see, Spacebox. So if you look at Spacebox, so right now I haven't pushed my README. That's why we do not get the README here yet. But if we want to add license, what we can also do is we can go to GitHub and click on create new file. And when I go to create new file, and when I type this keyword license in capital, I see this new sort of button that GitHub has given me, which is choose a license template. So again, this is GitHub recognizing GitHub being intelligent enough to know that, okay, if I type this keyword, I'm trying to choose a software license. And if I click on that, I can just add my MIT license, or I can sort of choose the different licenses, make some edits, and add this license. So I won't add this yet here, but this is one way to add license to your project. Now, I think what we can quickly do is take a couple of minutes where I think it'd be good for everyone to push their last code changes to your repository if you haven't already. So if you've added a README, please commit it, add it to your repository and push it to GitHub. And then choose a license. Look, like explore the licensing syntax in GitHub. You can choose right now to add one, or you can also just explore it and not choose to add one. But if we go through those two steps, I think it would sort of just, yeah, get us all on the same page and might help you understand licensing better. I'll just type those instructions in the chat. Uh, so yeah, just on those two steps, what questions do we have? And if not, yeah, please feel free to go ahead and do the commits and please put a green tick once you're done. Okay. Yeah. Chen, would you like to?
Sorry. For some reason I got an error when I tried to push my README file, and I've never seen this before. It just says rejected main to main. It says fetch first.
Did you make any updates to your GitHub remote repository?
Oh, I removed the file from there. Could that be it?
Yes. So if you do a git pull first, basically your local repository has one extra commit and your remote repository has one less commit. So like not one less commit, one less file, but the commits are out of sync. So first, if you pull those changes and then try to add your new changes, it should work.
Okay. Okay,
But
thanks. I'll try that.
if you do a git pull and then try to you might also want to do an undo commit, but uh, I'm just checking with you, Steve or Philly, if we should sort of look into the undo commit to get them in sync.
Yes, and most straightforward way would just be to pull and then push. I don't know. Did you say an uncommit? I don't think I've come across
I'm
that.
I'm wondering, as in like if Jen has made a commit locally, would that just automatically merge on the pull, or would it still again be out of sync in terms of the history?
Oh, I see. So the commit's being made locally but not pushed up to the
Hmm.
remote repository. And do you want the commit to exist or not?
I could do it again.
So if you try doing a git pull and tell us what it shows, but I can quickly show in case again this might be useful for folks, where sometimes you might need to do undo commits, where on VS Code there are sort of certain methods to do that, where you have these options here. Oh, this is not showing me the options. Uh, let's see. That might actually be under the extension that I do not have. But yeah, like there are ways to undo a commit through Git as well, where it gets the file into the staged state with the changes, but only removes the commit. So essentially, it is not in your commit history, and you can make changes to the commit history and then commit it again with those changes.
Yeah, so it's telling me I have divergent branches
Yeah.
and offering to either merge, rebase, or fast forward only.
So you could, again, yeah, I'm trying not to, again, add too many concepts all of a sudden for people. We will look into briefly into those options. For now, maybe a git reset might help, where we can do a soft reset, and that I think might help. So I'll paste the command. So if you try running this command, if you cancel the merge, so Control C should get you out of the merge, and try doing a git reset.
Okay.
And then if you do a git pull again, does that work for you?
Oh, yep, yeah, I think. Oh, no. No, sorry, it's giving me the same options.
Okay. I would suggest for now, like, either if it's giving you the options, either just sort of merge it and then push it again, or if someone thinks that, yeah, this is what like jumping into a breakout room and having a look at. But it's like I think just sort of one commit up and down.
I'll try merging it, thank you.
Thank you. Yeah, so again, just a general note for everyone. This happens quite a bit here and there, where sometimes, especially on projects that you are working with multiple people on, and someone made a commit and you did not pull it first, or you did not update your local repository first, you might just have two different sort of Git histories. So, for example, here we have the three sort of commits, but in certain cases it can be, oh, there are four commits, but the fourth commit is different on my local PC than it is on the GitHub repository. And that's when Git sort of gets confused, and Git basically tells us that, okay, these are two different commits and I do not know what to do. Would you like me to merge them? Would you like me to sort of overwrite one? Or the other option is you undo one of those, get them to the same position, and then add your commit on top. But yeah, so getting past the license, just again, quick checks. If we have any questions, any doubts, any thoughts on licenses? If not, we can keep going.
It's just a text file, no? Is that correct?
Yeah, but I don't think it has an extension. You can, I think, also do a license.txt that should also be detected by GitHub. But if you just use license without an extension, that's by default something that works both in software projects and with GitHub. But it is
Ah,
essentially text.
okay. So I just name it license. I don't have
Yeah,
to.
yeah. So if I show you one of the projects, but yeah, essentially, if you just name it license, basically, if you look at pandas, this is just named license without any sort of trailing extension, and it sort of gives us the text. By default, I think it's all in capital letters. So moving on from licensing, now we look at the citation file format. So like we were talking about it before, and we had a brief look. So the citation file format is again a file that provides instructions on how to cite our code, where it gives us all the necessary information on who the authors are, or how sort of you should cite the data sets, how you should cite the code. And it is easy to sort of access that information through the GitHub interfaces, where again, it's machine readable and it's human readable, where that certain format. So if we look at a YAML key value pair format again, is rendered by GitHub into a citation. And again, that citation can then be used in different platforms if you fancy. So just if we look at the format itself, this is what a citation file format looks like. So we have the CFF version, that's just sort of the file format version itself. But then we talk about the project itself. So it's the title, and then it's a general message, and the type, okay, what kind of project this is. So it's software, it's documentation on the different types. Sometimes we have the different file types, and then the authors. Now we have certain tools. So CFF init is an online tool that can be used to create the citation file formats. I will just sort of scroll by and show you how this looks. So if we quickly look at this, this is the example citation file format that we have for Spacebox. Now we just again talk about the type is software. Then we can have multiple authors. So we have three authors here. And then we also give it the repository code, an abstract, and some keywords. So some of this is accessible through the CFF init tool, which sort of guides you on the different ways that the different attributes that you can have in a citation file format. I can also show you the citation file format for this course itself. So if you look at the citation CFF for this, basically again, yeah, so it's talking about what this course is, then the type is data set, because so this is not software itself. And then we have all the authors listed here. If you have affiliations, you can add your ORCID. So there's lots of sort of meta information that you can add. Then we have a few identifiers, the repository code, the license, the version. So there are quite a few sort of variables that you can add to the citation file format, and it kind of helps you just get the meta information of any sort of software, any project. And then again, if we look at the citation of the repository, it gives us the citation in APA. So let me paste this into our code.emd as an example. So if you look at this, it gives us all the authors, it gives us the name of the course, and then it gives us the link to the course as well. So that's, again, quite a handy tool. If we look at the CFF init tool, I'll also add that. So this is the CFF init tool. Now, when we look at this tool, you have an option to create the file. And then again, it takes you through all these sort of different parts of citation file format. It takes you through, okay, what are the different resources, the abstract, the keywords, the license. A few of these are optional. I think author is, and the basic information are the required fields. And it generates a file for you that you can just add to your project. So I'll add this link to the chat as well. But yeah, I think we can move past if people are happy, because again, this is more of a general file format than like something necessary, and feel free to play around with it and add more stuff as you like. So if people are happy to move along, could we get green text? And also, yeah, if there are any questions, please do tell us. Any questions you have about citation file format, about licensing, about READMEs, and documentation in general?
So I have a question, please.
Go ahead.
The thing is that when we are creating our repository, so the steps are that we then go, after the steps we have followed up until now in this course, then we go and we'll have to create a license and a citation file. Is that how the flow will go?
So that flow is dependent on you, where you do not necessarily have to follow an order. So I'll show you. If I try to create a new repository, it will basically give me an option to choose a license right away. So I can choose a license right while creating it. I don't think GitHub gives us a default way to create a CFF, but you can just sort of create a repository and add the CFF first. So if you know, okay, this is the project title, this is the information, these are the authors, you can add it right away. So a lot of the meta information or the documentation about the project can come at any stage. So, but it's like kind of the general order of things where all these three, I think Alex also mentioned this. So README and licenses are good to add right away. Sometimes they get ignored if you know what kind of files you don't want to track with Git.
Yeah.
Uh, but once you have the basic structure, a few of the documentation files come later. So contributing, for example, usually comes later. Again, depending on how you build the project. And okay, now I want to add more people to this, or a code of conduct even, and same with CFF.
Okay. Thank you. So when you were showing the license, so like make a new file and then choose a license, it asks us to save a file and then says something like, would you like to? So are we going to just save it and then, go along and,
Yes. So I
okay,
can
so,
do that on my repository to show people an example. And again, one
yeah.
important thing to remember there would be that we'll need to pull this to our uh, main branch, to our
Okay.
local repository. So I have added a license, but let me show you on a template repository. Okay, so it's a test repository and I've not added a license.
Yeah.
I create a repository. Oh, it might not let me add. Let's try that again. I'll need one file probably for it to give me something that's just a template name. And okay, so let's add a README. and create a repository. Now, when I create this and I go to add, create new file, and I go to license, it gives me choose a license template. Also, just to mention that this is just sort of an easy way to add license related to a project. You can also take, say, any of the standard files where you can take the text of the MIT license, add it to a license file to your uh, local project and push it to GitHub. It will have the same effect. But this is again just an easy way that GitHub provides us to sort of add license. Now, again, when we're doing the commit changes, this is basically the similar process that we've been using through the terminal, but this is the GitHub interface of adding a change. So we do add license and I commit directly. So when I do this, this is essentially doing a git add and then a git commit. And now I have a license file. But what we need to keep in mind is, again, if I have a local project, that would need a git pull first to make sure that this online change gets on the local branch first.
Yeah. Okay. Yeah. Thank you. Thanks.
Thank you. Any other questions on any of the things that we've discussed? So licensing, CFF, documentation in general. Okay. So I think we can keep moving then. Now we'll look at a tool called MKDocs, which is kind of the tool that we were talking about. Now, MKDocs is a tool that helps us look at documentation through doc strings. So again, like we were talking about, what would be, say, what would be the stage for adding certain kind of documentation? Or again, at what point do you add, right in the beginning, or how complex a documentation can be? So like we looked at pandas, where they had documentation in their README on their GitHub repository, but also a dedicated website for documentation. It varies through the complexity of your project, but uh, here, again, the example is that, if you have a certain level of complexity, you might want to add documentation, which is sort of the standalone documentation. Now, we have used README as a primary source of documentation so far, and now we need to consider how we sort of distribute our code, or how do we sort of add more essential documentation to our project. So we look at one of the tools called MKDocs. And what we'll do is, what MKDocs does is it creates a static site, which is again a popular solution for getting documentation that is self-hosted for a project. And it can again be used to get all the documentation that you might have done at the code level while you were, say, developing a project, and get that out automatically. So when we look at a lot of the reference documentation, it is not people retyping or not people adding all that information again about, oh, this function in pandas or this function in matplotlib is written this way. It is essentially a lot of the coding that you do can have certain information that these tools can pick up. So it will make sense in a minute. I'll go to my project. So now, if I do a git log, I have the README, but I have not pulled the license into my local repository. So I will do a git pull. Now it shows us that the license has been added. So this is a license file that we created on GitHub. But again, this file can be created in within VS Code on your offline sort of setup as well. Okay. So just to check, is everyone at the same stage of the repository? So two major checks would be that if you have both your local and your remote repositories in sync, and if you have activated your environment. Could you give us a green tick if both of those are true? Okay, that's great. So I see quite a few green ticks. Now what we will do is we will install mkdocs into our environment. So we'll say Python 3 pip install mkdocs. I'll add those commands to the chat as well. After that, we will install a couple of related mkdocs tools. These can all be run all together as well. I'm choosing to run these separately. So we'll now install pip install mkdocs strings Python. And then finally, we'll install mkdocs material. I'll let that install and also add these. See the installation instructions. Okay, so all three of our packages have been installed. Now, once we've done the installation, we've got all those three packages. What we'll do is we'll initialize an mkdocs project, which is sort of our documentation project in the root of Spacebox. So I will do mkdocs new and then dot, and dot is the current location that we are in. So when I press enter, you should see something happening. So yeah, we see there's a new folder here with docs and an index.md, and it says welcome to mkdocs, and it has some information. So this is being done by the package itself by default, where it has pre-populated this format, this folder, and some general placeholder information there. So if everyone has been able to install mkdocs and then run mkdocs new dot to get this folder, could you give us a green tick again? Thank you.
So when I do mkdocs new here in this dot, and when I open this on VS Code, I just see site name my docs. I don't see what you are showing on the screen. Did I do something wrong?
Where do you mean? Do you see that?
So you have just okay. So it's index.md.
Yeah, it's index.md that it creates for us. Basically, these are just the initial config files. So it creates like an mkdocs YAML and an index file for us to add a documentation.
Okay, yeah, thank you. I can see that.
Okay, perfect. Okay, so if people have been able to initiate.
Aman, I don't think
Yeah.
I have it.
Could you share what error you're getting?
mkdocs new options project error, missing argument project directory. I don't know what I did wrong.
Did you add the dot? So the dot is the project directory where if you are in the root folder Spacebox and you do mkdocs new space dot, that
Space
should.
dot. Okay. Yes.
Okay. So did that create the same docs and YAML for you?
Yes. Sorry about that. Thanks.
Great. Yeah, no. Again, yeah, this is kind of like just the bash syntax where certain things like these are easy to miss with the dots and the dashes or the sort of mini arguments. So sometimes again, like this is also helpful that mkdocs tells us that, oh, you've not given me a project directory, so I'm expecting something. So for example, if I wanted to create my docs inside tests, I would say tests and forward slash to tell mkdocs to create those folders uh, within this location. And by dot, we just mean by default, the default location we're in, the base location we're in, to create it there. Okay, so if folks have been able to create the mkdocs and everyone has the YAML, let's configure the YAML and let's get our mkdocs setup running. Let me see. Okay, so yeah, by default, it has just given, what we were referring to before. It's given a site name, my docs, again, because right now we have not configured it to do anything. Now I will remove this. And again, in interest of time, and like since we've used YAML before, this is the this is the structure that we're using and the information that we're using to create a documentation. So this is very similar to the YAML we were using before. I've pasted this information in the code EMD as well. So if we look at on what is going on here, we can go from top to bottom and look at what every line is defining. So first we say that the site name is Spacebox documentation. And then the use directory URL is basically telling mkdocs to how to handle the URLs for the documentation. And we look at how these different pages serve as the URL that we have for our website. Then we sort of tell it the theme is material. So this is one of the packages that we installed, which is the material theme. And again, we don't choose a font. That's for GDPR compliance. And then we give it the nav, which is basically these are the 5 pages that we want, and these are all markdown files. So again, we're not creating these files yet. We are just giving uh, mkdocs the configuration that we want in our documentation. So this is the structure of the documentation that we want. Now, once we have the base structure, what we want to do is we installed another plugin, which was mkdoc strings. And this we can list here, and we can say mkdoc strings as plugins. Now we have this file. That's the final version of the file. We'll save that. Again, I'll add that here. And once we have created this, what we'll do is we'll create all these files that we have mentioned for mkdocs to have in its structure. So index has already been created for us, so we don't need to create an index. But the rest of the files we can just create using the touch command that we've used before. So I will oh, yeah, so that's the path. Okay, I don't need my index. Tutorials, how-to guides, and reference. Okay, so when we do this, we have all these new files that we asked mkdocs to have in the configuration as well. So again, we've just used the same files as we provided in the YAML, I'll provide this command if that's helpful for folks to copy. But essentially, yeah, we're creating new files. You can create these manually as well by creating a new file, creating a new markdown. But we are just trying to add the essential information. So if people have been able to create the YAML, configure the YAML, and create the new files, if you could give us a green tick, please, that'd be very helpful. Okay, I see a few green ticks. That's good to know. Perfect. So once we have that, what we'll do is we'll go to reference.md and we will add a preamble here, which is just again the general information about this file, which is this file documents the key functions and it is provided as a reference manual. And then we give it this keyword and we link it to ever data analysis. So this is for references.md. And this will help us generate a reference manual from the doc strings that we've created. So we do that. And then once we have added the preamble and the reference, we do mkdocs build to actually build out. Wait, I'll first clear the terminal. And now we do an mkdocs build. What this will do is build the documentation for us from the doc strings that we have used in the project already. Oh, okay. So there's a warning. Right. So I think, yeah, we haven't updated essentially the mkdocs, but yeah, they're telling us that this might not have, this will introduce backward incompatible changes. So in a certain time when this is not supported, it might be difficult to interact with the latest mkdocs packages. Now, this again is an example of what we were talking about, say, documentation, where they have documented this warning right within the installation, where it shouldn't be an error. It should still run for you. In fact, uh, at the end, it should say documentation built, and you should have this new folder called site with all these HTML files. So if you are able to run and then get this folder called site with these pages, could you again give us a green tick?
Sorry, I think I just missed the last comment. What are we supposed to run? I did
So
finish the
mkdocs
reference
build.
file.
Yeah, so mkdocs build is the command
Okay.
that will give us this site, which is again essentially the command we use for running mkdocs, building the site from all the information that we've given it.
And we probably don't want to put it into the repository, right? Because it's automatically generated stuff. So
You can, like, depends on how you structure your documentation. I mean, I haven't pushed it yet, or I haven't decided yet. Just look at the error. Did you configure your YAML? Did you add the plugin to your YAML for Basabdata? Because it says config values plugins invalid configuration. So if I look at my YAML again,
It's
this is the end. Sometimes again, YAML can be a little faffy with the spacing as well.
So I think it's the font option is supposed to be indented by
okay,
two spaces.
okay.
So Aman, that's a mistake in the text above.
Oh, right.
You see, under theme, font needs to be indented
Oh, okay, okay.
because it's a part of the.
But wait, I'm wondering why it ran for me. Because for
That
me,
is
it
odd.
only gave me a warning and still ran. So it gave me a
Okay,
warning
now
again
it ran.
that it's unrecognized.
So it won't use it.
Yeah, but it should not give you an error.
That's the error is different. Sorry,
Yeah, so the error might be
but at
different,
least
but yeah, good
that's
spot.
still a.
Yeah, let's try that again. So I run mkdocs build, and yeah, now that warning has vanished from our message. So, okay, we're getting a couple of errors. So the first one, uh, I'll walk through the steps again, and yeah. So thanks, Steve, for adding that, where we install 3 packages in the beginning, and then we configure our YAML. So for Gen, there is the list that has an error. Again, it could be just the format of how you have the YAML. So again, for reference, if we look at this YAML file here, which is marrying it between the dashes, this is what your YAML file should look like for mkdocs, which should give you, yeah, the exact YAML that we're using. And these are the 3 packages that we've installed. And again, you can install these with a single command as well. So these 3 packages are the packages. So we install the packages, then we do an init where we initiate our mkdocs, which gives us the index.md and the YAML. Then we add this configuration to the YAML. After that, we create the markdown file. So 4 markdown files that we told mkdocs that we'll be using. And finally, we add this preamble to references.md. So the init step is mkdocs new dot, which is, I'll paste it here. Let me pull up the material so we can look at the step-by-step things. So, okay. So we have, first we install the 3 packages. Then we do mkdocs new dot in the base location and make sure that we get the initial files. Once we have the initial files, we should get an index.md and YAML essentially. We add this information, this configuration, and we've added this same configuration in the codemd. And once we've added the configuration, we add the 4 files that we want in our configuration. So we create the empty markdowns. And finally, we go to the references.md and add this preamble, and then we run mkdocs build. So I'll give people a minute and ask again to use green checks or red crosses, depending on what is your status for mkdocs. Also to check with Jen, Asaptata. Okay, I see green ticks.
Yeah,
Promptio,
that's sorted for me now. It has
and
built
yeah,
without
basically
errors.
the people who were getting errors or warnings, if they're able to sort of run everything smoothly. This is something I'll make a note of.
Sorry,
Mention.
okay, so the adding the hyphens with the space did sort the nav error, but I'm still getting a theme error, unrecognized theme named material.
Have you installed this package, mkdocs material? So if you,
Yeah, I ran all the 3
okay,
installations in one,
okay,
but I can try that
and
again.
And the name material is in double quotes, I'm imagining. I mean,
It
it's
says the available installed themes are mkdocs, read the docs material.
yeah. So wait, then I'm confused. If it's available, then it's
Yeah,
not
so am
installed.
I.
Yeah, and I guess yeah, like if you just want to remove everything and then copy paste again from the code EMD, if sometimes it introduces just random characters. If not, uh, we can probably debug it in a bit.
Sorry, when I did the MacDocs dot, I just
Hmm.
got the first info message. I
Okay.
just got the first info message and not the one with the doc index.
So when you did the initialization, of
Yes.
okay, and that's when you did you not get a YAML?
No, yes, I did. I did. It's just like in this where in the page where you are in the outputs,
Oh,
it says two outputs.
so do not again if do you have both the files, the index and the YAML?
Um, I don't see the
Essentially,
index one. I just see the YAML.
okay, interesting. Essentially, I mean, these messages change from time to time, so do not particularly
Okay.
worry about the message itself. But yeah, you should have uh, a docs folder with an index.md inside it and a mkdocs YAML.
Oh yeah, yeah. Now I can see it. Okay, okay, good.
Yeah,
Yes.
so
Thank you.
sometimes the info messages update or they change it, or sometimes again just like bash scrolls.
Oh
But yeah,
right. Okay, thank
we perfect. And again, like if we look at the info messages, these might be different for people depending on the code stage. So it depends on again what the different versions you're using, what's the updated stage of your software. I see lots of green text. Okay, so that's good. Now, what we'll do is, if everyone has been able to generate it, we will go into, let me clear this. We will go into our site and we will look at our index and open this in a browser. So, okay, I'll just use my Finder to locate it. But basically, if you go to your file browser and go to the location of where you've created this project, you should be able to find that HTML. And if you open that HTML in your browser, let's see. So it's under site. Now, if I go to index.html, this is what I get. Now, the default page remains the same. We have not added anything to tutorials, how-to guides, but when we look at the references, this is where the magic happens. This is what we were talking about, the auto generation of the references, where we have added these functions to our code and we've given them doc strings. Uh, we've written a line talking about what does this sort of method do, and then it looks at what kind of type it uses, what kind of parameters it has, what it's returning, and that basically again generates all of this automatically. And it tells us the source code is in this file as well. So this is again the auto generation that we were talking about. If you look at sort of the website itself, again, if we add something to tutorials in the Markdown, this will just sort of populate here as HTML, but all of that is being done by mkdocs for us. What is essential to remember is whenever you make a change to one of the Markdowns, you will have to do the build command again, because the Markdown itself is not will not render here. but mkdocs does that for us, where it converts the information in the markdown, renders it into HTML, and then gives us the sort of essential responses and generates that website for us. So if folks have been able to run the command and then again access the HTML, so your URL might look something similar to this. So depending on where you have the HTML situated, you can also just go to your browser and add sort of the add the URL to go to the website. If people are able to see the automatically generated reference, could you give us a green tick, please? Also, what questions do you have? And if people are still facing any errors or have, again, any further questions about mkdocs?
So are we supposed to see? So what are we opening? Sorry, I'm completely lost. So are we
So,
supposed to see? Yeah.
Go on. You were asking questions, sorry.
Yeah, so after, so I can't see this HTML under spacewalks folder anywhere. There is a,
Is
yeah,
there a site folder?
no, okay, yeah, there is a site
So
folder.
yeah, if you look
Okay,
at the site folder, it should have the HTML where mkdocs has put all of this in a site for
okay,
us, and that's
yeah,
the HTML.
got
So
it.
again, just a way to verify if you want to open it in your browser, before opening in your browser, if you go to your reference.html, it should be quite populated. So like mine is like, yeah, over 1400 lines. But here we can see it has added all the information. It has pulled all the information from the other sort of spaces where, yeah, the explanation you can see is much sort of smaller, and same for references. It's below 400 lines because those are just the default sort of HTML pages. But I'll wait a minute.
Hi,
Yeah.
Aman. I wasn't able to save the change in the YML in the mkdocs. So I just see the generic my generic my mkdocs documentation. I didn't see the spacewalk documentation. Should I just regenerate it, or you get
Yeah, so if you have the YAML and this is the configuration in the YAML, and if you've added this preamble into your reference, you
yeah,
can just do build again and should give you the
uh
populated website.
just build again and it will
Yeah,
update
which
the
is
miss.
again, I'll show people an example of, so if I do say in my tutorial a sample text, this would not show up in the tutorials by default.
Yeah.
But if again I go to my terminal again and do the build again, this will basically take that data from the markdown and build it into the HTML files. So now if we reload tutorials, it shows sample text instead of tutorials.
Okay.
Okay, so I'll wait a minute. If other folks have been able to generate this and could give us a green tick, or again, if people have any questions or any errors or any general, again, questions about mkdocs, even if you were able to successfully build the website. Okay, I do not see anything in the chat. Now, if we've been able to build that, yeah, so this is again kind of a way to have sort of, yeah, dedicated website documentation hosting where you can just sort of look at the different kinds of documentation that you have. You can add the different sort of elements. So we have added how-to guides, an index, an explanation. All of this can be populated as you sort of uh, try to build up your project. Now, before we do anything else, we will just sort of commit everything that we have and add it to our requirements as well. So first, let's add our mkdocs.yaml, our docs, and our site. And I will commit this as git commit, and I'll say add dedicated documentation. So that has committed all of the major changes for us. Now, what I'll also do is, so this is something to keep in mind. And again, there are different methods to do this, but the basic method we're using here to make sure that our requirements are updated is using a pip freeze, where a pip freeze basically takes all the output from whatever we have as our dependencies. It takes all the requirements. So if we look at our requirements.txt, currently it has 20 lines and it has all these packages. Now pip freeze will take all the current packages that we have and add it to requirements.txt. Once we pipe it into requirements.txt through the Angular bracket. So we do that, and now we see it has added more packages. I think for me, it will add a few of the other packages that I had in my environment. But again, this is a good way to look at what are the sort of dependencies you're using. And now that we have a change in our requirements.txt, I'll add that and I'll commit it. Update requirements. And finally, a git push so that our remote is updated. So what we've done is we have first committed the docs, the YAML, and the site, and added that as our documentation. Then we did a pip freeze, which helped us update our requirements, and then we pushed everything to the remote. Okay, so if I just look at my repository now, I can see that we have the updated requirements, the mkdocs site, and the overview all over here. I'll just quickly clear the feedback. And if people can again give us screen text, and I think Chen, you had a hand raised as well.
Yeah, so I just have a sort of curiosity question because so like the MK docs and these last ones that we got, they're kind of just needed to make the documentation. Is it necessary for us to add it to the requirement text, which isn't the requirement text just for what people need to make the project?
Yeah, you're right. So that is not necessary. And in fact, again, once we get deeper into the practices, there are certain ways to make the requirements better, where certain projects have, when you do a pip install, you can add documentation in bracket or developer in bracket, and it installs certain part of those requirements where it does not necessarily need to be packaged with the main software. This is what we've chosen to do here, but feel free to skip it as well. But yeah, if everyone has been able to build their documentation and follow along, could we get a green tick? And if people have any questions or anything else. Okay. I think we're coming up to a break. I'd say we could take a 10-minute break before the sort of last stretch. Uh, But yeah, if there are any questions. Okay, so let's take a 10-minute break. We'll be back at 11:55 BST. And if people have any questions, I'll be around. Or if you have, again, any doubts, anything about whatever we've discussed today or in general during the week, please feel free to ask that. All right. Hi, folks. As people are coming back from the break, could we have green text? Perfect. I see a few green ticks. Okay, so this is the last stretch of the course where we'll talk about collaboration and software management. So let's have a look. Now, this sort of section of the course is a lot of, again, I think with today's theme, it's a lot of information sharing on like how things work with GitHub or how things work on the overall project level. So we'll mostly sort of look at the different features and explore kind of what different uh, ways there are to sort of manage a project or share our code or archive our code. And there are more detailed sort of exercises, there are more detailed ways to go through these sort of practices that we look. But again, we do not probably have the time or the infrastructure for sort of doing more interactive practices. Those take quite a bit of time. But yeah, we'll go through those. And as we go through, uh, I'll keep checking, but please do jump in with any questions or any doubts or any concepts that might feel unfamiliar or unobvious to you. But yeah, we'll explore on what all you can do with GitHub and with your code and how you can sort of publish it and manage it in a more sort of fair way, in a more reproducible way, and using sort of best practices that we have for code sharing. Okay, so hoping most people are back from the break now. Now, what we look at is just sort of a few different GitHub bits around how we sort of make our code public or how sort of we change settings or how we can again use the GitHub features to sort of change the organization of our code. So, for example, with this repository that I have, Spacebox, which is under my own username, I have full admin rights to this repository. Now, here I can go to settings. So, if you go to the Spacebox remote repository, and if you go to your home page, you can go to the settings, and on the settings, you'll see all these different options that we have for just sort of managing our project. So there are ways to add collaborators where if I go to the collaborators, let me just do that. Basically, this will allow us to add collaborators on different levels to the project if I want, and it helps us add people in different capacities. So as an admin, as a contributor, you can also manage the different levels of access. So here I can add people. So for example, if I add Alex and click on add in an image, it will send Alex an invite. And once Alex accepts the invite, we'll see that she's on the project. So that's one way to sort of add collaborators. Now, if you look at the general settings, again, there are quite a few things where it also allows us to enable or disable certain features on the repository. So for example, we see the wiki sort of tab on top right now, and this is where we can create a wiki about the project. But say that I did not want to use the wiki, I click on it again, and that removes the wiki tab where now there is no tab for adding wiki because we realized that we did not want to host our documentation. But this is all again quite sort of GitHub centric features. These are not directly in Git itself. These are just sort of ways to present the project itself. There are also discussions that you have on certain projects where community projects have certain discussions about, oh, if you are wanting to, ask a question or sort of open up a discussion about a certain part of the project or a general question about, say, governance of the project, you can go to discussions. But then we have the issues as well. So we have issues, pull requests, actions we've looked at. These are the different ways that you sort of collaborate and engage with the project. Now, for example, if we go to the bottom, this is called the danger zone. These are kind of the permanent sort of settings for like making sort of project-wide changes. Not permanent, but in the sense that, say, if we do a delete repository, we cannot recover this on GitHub itself. So if I do a delete repository here, if I do delete this repository, it will ask me again and ask for a confirmation. And if I do the delete this repository, it will remove it from GitHub. My local repository will still exist. My local code base will still exist, but it will remove it from GitHub from here. There are other sort of methods to sort of change access. I can transfer ownership. So I want to transfer, say, again, a project to someone else that I want to make the admin of. I can use transfer ownership. And this again gives me an option to, uh, yeah, choose an owner and give it to someone else and provide them with all the sort of admin settings. You can also change visibility. So currently, this is a private repository. If I change it to private, that won't be visible to anyone without explicit access. So it won't be accessible on a public link, where if I've added collaborators, only then they'd be able to see that, and I'd be able to see that, but no one can access the project publicly if I change that setting. You can also just again change or transfer ownership to an organization if you want. So certain times it's like, oh, you start with a personal repository or you start with a personal project, but then it needs to be built into, say, a team organization, or it needs to go under a collaborative organization space that can have sort of various models of ownership. We can also do that. So yeah, lots of sort of admin changes that you can do through the GitHub settings. So again, there are other settings around how you deal with commits, how you deal with pull requests, how you deal with issues. Now, again, if we look at the left-hand side, there are all the different sort of ways you can change things. So I think the new additions, models, or even sort of stuff around Copilot is new because GitHub has added those as sort of the more current features. Actions again helps us change the runners or like how the actions are running or what kind of settings we want on a very sort of system level for the repository. And that is the same for, say, adding rules to branches. So for example, if I go to my main page, it says my main branch isn't protected. So usually the precedent that we have for pushing to main branch or working with the main branch is that the main branch is the sort of protected and the more refined part of the code. And what we end up doing usually in, again, in a collaborative project, in a general good practice sense, is that we work on other branches, on different branches in the project, and then merge them to main, but do not make changes to main directly. That is why, again, GitHub recommends us to protect this branch, which is that before I make any changes to main, it requires some kind of authorization or it requires some kind of confirmation. For example, if I provide access to Steve for this project, I can choose that no one but the admins can sort of make changes to main. So Steve might be able to add a new change and push it to another branch. But if I do not provide admin access to Steve, he would not be able to make changes to main. And he can request me to make changes to main and I can approve them. But these are again certain ways that you can manage access or sort of work with collaborators depending on what kind of uh, what kind of power to the project that you want to give them. Now, one sort of interesting bit that might be of use to a lot of people here is looking at archiving and generating a DOI, a digital object identifier for, say, a repository. So that can be basically done through different providers, and one of the popular ones is Zenodo. So Zenodo is a service which is hosted by CERN, and this is kind of a data hosting platform, which is it's a data archive that is run by CERN, which allows us to upload up to 50 GB of free data, and it gives us a DOI for that project. So I'll show you an example. So if we look at this, this says it's a software project, and I'm just going on the homepage where it is by the Swedish pathogens portal. And if we scroll down, we can see that there are all the code files that we have on our GitHub repository, but they are now archived into this data archive, and it's given to us as a zip file, and it gives us sort of certain identifiers that can be used for like reference to the project. So for example, I can see the linked GitHub repository here. And if I go to that repository, it should take us to the original source code. So this is, for example, the original source code that we have on GitHub, but they have linked this repository to the Zenodo. And now essentially, whenever they push a version change to the repository, it gets pushed to Zenodo, it shows all the authors, it gets archived and generates a DOI. This is the DOI, for example. And again, a DOI is the unique sort of record of that file, of that artifact. So it can be a data set, it can be just like an archive of content, it can be an archive of software. But yeah, if I go to the DOI, it will take me to Zenodo again. Now, there are different kinds of DOIs. This one is linked to Zenodo, but certain DOIs take you to different sort of portals. So research papers and journal articles also use DOI sometimes, especially a lot in the open access community, where it's a unique identifier, and that unique identifier will sort of give you a permanent record of that artifact. Now, another sort of way that we can do this is kind of link our GitHub to our Zenodo. Now we can archive our GitHub repository to Zenodo by going to the Zenodo sandbox. I'll show you what that looks like, and if people want to play around. So this is the Zenodo sandbox, and I sign in with GitHub here. Now it is asking me for authorization where I want to link it. So I authorize Zenodo to link my GitHub account. And once it redirects, so now I'm logged in with my GitHub profile and has linked the profiles, and it has provided me access to the GitHub integration as well. Now, what I can do is I can go to the settings here and go to GitHub. And here, because I have linked my repositories, it shows me all the repositories that I have, and it allows me to flip the switch. It also tells us how to do it. So I can flip the switch and create a release and get a badge. So let's search for Spacebox, for example. And if I turn this on, what that basically does is it will create a repository for me. It will link my Spacebox repository to Zenodo. Let's see. Where, okay, I will need to create a release first. So I'll do this as an example exercise. Again, you can sort of play around with it, or you can create releases for different projects. So it takes me to this, where, for example, if I go to create a new release, and let's say Zenodo as the tag, and I create a Zenodo tag, and I add a title, and I click on generate release notes. Again, it just sort of gives us the full change log, and I publish this release. So once I do this, it essentially should archive this release on Zenodo for us. So now if I go to that DOI, so this is just like us being too quick, where it's being generated, it will take a couple of seconds, but this DOI has been blocked by Zenodo for us. And I think in a couple of seconds, it should just sort of show us the updated page. For now, it's not going to it. But essentially, again, this is a unique identifier. What do I click on archive first? Let's see. I'll give it a couple of minutes, but basically it gives us a DOI that essentially, again, is the unique URL that we can use, the digital object identifier that I can use to get to the repository like we saw with the other public project. This might take, I think, a couple of minutes, but essentially this is one way that you can archive your code, and it will help visibility, it will help archiving, it will help sharing, but it takes a snapshot of our repository at the point we create the release. And now this means that even if I were to delete my repository from GitHub, this will always exist in Zenodo as an archive because it has taken a snapshot. So there will still be a copy on Zenodo that exists, and it will still allow people to download the entire repository from Zenodo as they sort of want. Now, Zenodo will create two DOIs. One would be the sort of overall DOI, which would always take me to, say, the Spaceworks project. And then as I do more releases, it will add to that DOI and give me the newer versions. But as we can see, it also gives us this badge. So if I click on the badge, I can get the link to that badge. And that badge, again, if I add to my markdown, should show me the Zenodo badge. I'm not sure if it will be rendered in VS Code, but yeah. So if I add that link to VS Code, it does give me the Zenodo DOI. Still not generating it, which is surprising. Oh, my bad. We are in the sandbox. I am trying to access sandbox link. So yeah, sorry. This is the sandbox. So we do not actually create the DOI, but this is the example of like, yeah, having a DOI, getting a badge, and then archiving it. And once we sort of publish it on the main Zenodo.org, if we, instead of the sandbox, use the main Zenodo instance, it will generate that DOI for us. So that's one way to add a DOI. Now, this DOI can also go into our citation format. Now, if I look at the other project, and if I see if they have added a DOI, they haven't added it here. Let's see if we can get to, okay, maybe the course itself might have one. Right. So if we look at this line, here we have the Zenodo DOI record for this lesson in the material. So if I go to this DOI, it should take me to the archive version of the course. And again, as you can see, once we do the releases of the different versions of the course, it archives it for us and it gives us the latest version with all the information, and also gives us a unique identifier that gives us a way to manage our code and sort of, again, have a public, reproducible, and downloadable data set from the material itself. So this is an example from the course material repository that we've used here. But again, you can do this for any kind of repository and link to GitHub to archive stuff on Zenodo if you would like to, again, get your stuff in a more permanent fashion. There are other sort of repositories as well that are used sometimes, but again, it depends on what kind of project you're looking at. For software, for a lot of data sets, Zenodo is quite the popular one. and it works quite well. It is quite sort of integrated within GitHub. So it's an easy way to sort of just test out things or make sure that you don't have to do it manually and it generates everything for you. Uh, just before we move on from this to collaborative bits, I'll wait a couple of minutes and I'll just check, yeah, what questions do you have? Anything in general about DOIs or archiving or Zenodo? Or any thoughts you might want to add? Okay, I do not see anything in the chat. So now what we'll do is we'll look at the different ways to sort of interact with the project using issues, pull requests, and branches. So this is again kind of a major feature in GitHub. It's a major way of how you collaborate, how you interact with the code, or even on just your own project itself. These are ways that you can track certain sort of features, track certain issues, bugs, or just information, and you can do it in a systemic way of keeping track of your code base. So, for example, we have spacewalks, and now I want to add, say, the documentation. But instead of adding the documentation like we did directly, I might want to say first create an issue saying that, oh, create documentation for this project, which is essentially just a way to, yeah, record something that, okay, this is a task that we want to do, or this is something that we want to fix, or this is something that we want to add to the project. You can use it for a lot of different sort of areas. And then what we do to sort of work on those issues, if they are actionable issues through a change in the source code, we make those changes and then we make a pull request, which is essentially adding something which is a proposed change to the codes to the GitHub code base, but we do not sort of directly add it to the main or directly add it to the main code base. So unless and until these pull requests are merged in, it won't go into the main source code. For example, I think Dependabot has opened a few automatic pull requests, which is just like, yeah, sort of bumping up version numbers for packages. You might have pull requests in your repository as well if you use certain packages. But again, this is because I think I had a few extra packages in my default environment. Now, what this has essentially done is it says Dependabot has created this pull request and it's asking that there is this branch and Dependabot, again, this is a bot, but this can be any collaborator, is wanting to merge from this branch to my main branch. And again, I can just sort of go to the files changed and I can look at, okay, what are the changes? And let's say I want to say change not required. And I tell this sort of collaborator and I want to just sort of inform them that, okay, I've reviewed their change, but I don't think this change is required. And I submit a review as a comment here. What this will do is, again, this just sort of adds my comment on the same pull request. It gives us a record of what is the discussion around this particular pull request, this particular feature, and how, say, it's being merged or it's being closed or what is being done with this pull request. Now, instead of merging, what I want to do is close this pull request where I do not want to merge this into my main code. So if I click on close pull request, it basically again tells us that it has been closed with unmerged commits. And again, I guess, yeah. So Dependabot has certain features. It knows that, okay, that I've rejected the change. So now it will not notify me again for this release. And I can set it to sort of not do the automatic changes for me. But again, this can also be used as an example for, say, a collaborator, or either say if two of us were to work on a project and I make a change and I'm like, okay, we can update the README like this and we can add these patches. And if you feel that, oh, those patches would be useful for your README, you can merge those changes. So for example, I go to pull request again and let's bump a PyTest. So I can directly just merge these changes as well. I can say merge pull request, and that will directly merge these. And a review is kind of like an additional step which sort of helps sometimes to review changes where I'm like, okay, I want PyTest to be changed from 9.0.3 to 9.0.2 instead. And I can recommend that to the person who's opened the pull request and they can make those changes. Or I can just sort of approve this as well. So I'll just sort of add a general comment where I say it looks good to me and I approve it. Now, once I approve it, again, it shows that I have approved these changes. It adds that comment and it gives me an option to merge that pull request. And I will do a confirm merge here. So once I do that, now what we'll see is that our main code base has these commits. So we can see that dependabot made a change, and now that is in my commit history, and that I have merged that pull request. That is also added as a commit because we merged by default by adding a commit, which is called the merge commit. Now, if I look at my local branch, my local folder, and I do git log, we'll see that those latest changes are not added here yet because we haven't pulled any changes from the dependabot pull request. So now what I'll do is if I do a git pull, I'll see that those changes have been added and it shows me that this is the commit that dependabot made. And again, as we could see on GitHub, this is the change that was made and we can merge it. Or again, like if it is not merged, you can request a change as well. Same for our git log. So if I go to git log again, it is showing me, oh, that dependabot is one of the commit authors, and then I made the merge commit. So now both the repositories are in sync on the remote and locally. Now, there are, again, different ways to work with issues and different ways to merge. I'll show you again a couple of these. So another pull request that it has created, and I see this little arrow here, which can be used to sort of merge in a different manner. So the first one that we used was create a merge commit, which added another commit on top, showing that I've merged this pull request. The second way to do this is squash and merge, which will only give me one commit for this change, and it will basically make the merge commit and dependabot change as one commit. And rebase basically takes the commit and rebases to the base of the branch and then merges them. So these are again different ways to merge different branches. So this is not just within GitHub. This is also something that you get sometimes when you have a merge conflict, or like we saw earlier, if there are histories that are not matching, or if there are, say, certain things that Git is asking you to merge, it can ask you to rebase and merge, squash and merge, or say resolve a merge conflict. So let's try squash and merge here. And once I do this, let's go to our code again. And now I'll see that there is only one commit by dependabot. It does not give me another commit, which says that, oh, I have merged the change, which is again the additional merge commit that sometimes some projects prefer. There are different methodologies to do that. Now, just to check, when we talk about issues and pull requests and the general sort of GitHub interfaces, has this sort of made some sense so far? Because again, we're doing kind of an overview. It can be a new concept and we can get into the practical, But before we do that, I just want to check, yeah, how people feel. So green text, if you feel that made sense, or any questions, any red crosses. Okay, so I see a few green ticks. Now, what I'll show you is basically a workflow on how we do the issues or how we sort of make a change or interact with our local and our remote repositories. Now, these can be done different ways. These can be done from like the local to the remote or the other way around, or again between two collaborators. You can move a lot between the branches, or you can sort of move around the stuff that you want to sort of get to a certain part of the project, or you want to create a release. We look at one of those workflows, but yeah, I do not expect folks to follow along on this. You're welcome to, but again, we're doing sort of just a demo of how this workflow might look like. So, for example, we create an issue where we want to say, yeah, we want to add something to our space box. Now, again, this is the issue that I can create. And this is, again, just to document what change I want to make or what feature I'm proposing, or maybe to document a bug. And what this helps us do is, again, keep track of the changes in the repository. Now, this issue we can then use to sort of track through our pull requests or in our branches. So, for example, let's say add a summary table of total EVA time by astronaut. So we have this as basically our key features where we tell the summary title, which is, okay, we want to add the total EVA time and a summary table for it, and then add a description, which basically, again, adds certain description to what do we want this change for. I can tag people onto this. Let's see. I cannot tag on this one, I think, because I do not have any collaborators. But once you have collaborators, you can add different people to issues. Now, let's just create this issue and see what that does for us. So it's created this issue and it's also given it this unique number 5. So hash 5 is the number of this issue. Now, one thing to keep in mind is that the numbers between issues and pull requests are shared. So a hashtag 1, so if I have 4 pull requests and I open an issue, that would be hashtag 5, where both of these sort of indexes are on the same calculation to make sure that things don't overlap. So if you're talking about hash 5, or if you're talking about hash, say, 29, it will only refer to a unique thing, which would be either the issue or a pull request. But we do not have hash 29 as an issue and hash 29 as a pull request, which might again end up creating conflicts. Do we have any questions on this so far? Okay. So now that I have an issue, what I want to do is that to create this summary table, I look at this issue, for example, and I see this is a change that needs to be made, and I look at it on the online version, on the online project. So I go to my local repository, and now I think that, okay, I want to add this change to my main project, and I want to then sort of push this change or maybe try to merge it into the remote project. But where I'll start is on my local machine. So this is again kind of emulating a workflow where, say, I'm working on, say, the pandas project, and I see there's an issue, and I say that, okay, I want to address this issue. So sometimes again, you go and you claim an issue, you tell that, okay, I want to work on this issue, and it can be assigned to you. And once you do that, one sort of standard way to work on an issue might be to go to your own version of the repository and make changes there and then push them. So I'll first remove this change. Let's remove this patch. What else is modified here? Okay. So now what I want to do is to address that issue, I do not want to make changes to my main branch either. So what I can do is create a branch to address that issue. So I say git branch and our issue number is 5. So let's say 05 sum by astrofeet. So that's a feature I want to add, and I've named my branch 5 sum by astrofeet. That is referring to the issue number that I'm addressing and what I'm doing within this branch. So when I do this and I look at the branches that I have, it gives me these two branches, which are the local branches I have. So 5 sum by astrofeet and main are my local branches in gray here. And the ones in red, we can see it says remote origin and then the branch names. Those are all the branches that depend on what created to add those sort of updates to our project. So I can also see these because I added the -a there. If I do just git branch, it shows me the two local branches. And again, this is a good way to keep track of what branches are you sort of working on or what branches exist on the remote project. Now, what I want to do is I want to switch to my branch where I can use git checkout or I can use git switch to go to that other branch. Now, if you also look at the bottom left in the IDE, we can see we are in main. But once I do the git switch, this has also switched to the new branch. Now, a branch is essentially, again, a, a different sort of instance of the code. So currently, because we've not made any changes, this branch is exactly the same as the main branch. But now, say I add a change to this branch, we will have two versions of the code, one that will exist in this branch and the original in the main branch. And again, this is a way where I can add a feature which takes that version of the code, snapshot of the code, makes my changes and keeps that in that branch. And again, in certain contexts, you can have different features on different branches as well, where a lot of projects use main and development branches, where their main branch is, say, the version 2.0 of a software, and their development branch is, oh, there is 2.2, 2.3, but they don't want it to be the publicly accessible or the public package because they know, okay, that might not be as stable. But say when they do a 3.0 release, they might again merge it to main. And that's when both those branches track back again and get updated together. So this is again a feature and a methodology that is very popular in collaborating in GitHub. Now, what I'll do is I'll add my function. So let's go to our Python file. And at the bottom, I want to add this function. I'll add this function in case anyone also wants to make these changes. But again, this is more for demo purposes. So don't feel the need to follow along. So this is a method that we're adding to our branch that we've created. And we go back to our local file, we added this, and another one that we'll add, let's see. Okay. Now we'll add the duration. In fact, let's move this above. Yeah, above our main function, we've added this new code. And now, once we've done that, we want to save this into a CSV. So we've added the duration by astronaut file. Again, I'll add this in case folks are interested. So again, I've made these two changes, and now just to ensure that this is returned from our main, we'll add this as a parameter. So we've added the duration by astronaut output file as a CSV, and this is the function that is responsible. This is the function that is responsible for returning that subset. This is just standard code that we are taking from the code base to add a feature to this branch. Now, once we have done this, our script is updated to add this sort of function, but again, this only exists on the current branch, and again, we haven't committed it yet. But now, if we run our script, let's see. I haven't updated my script, so hopefully it will work, but let's see. It should have an interpreter. Okay. So main takes 3 positional arguments. Oh, I did not change the arguments in the other place. Okay. Let's try running this again. Okay. So it has created this table for me, and it has given us the CSV file. Okay. So we have both the CSV files and we have the graph from it. So that means the results were generated. So this again is a demonstration that we've added, say, a new feature that we wanted to add to this project. And now what we can do is we can create a pull request to look at what changes we have made and get them to the main branch. So if I clear this, and I do an ls results, I can see that I have all the 3 files. Now, what I will do is I will add this file, and I do not want to push results, but I can still push the changes that I've made into my script. And I can say add duration by astronaut function. So now this has made changes to our Python script, and we have committed it into the file itself. But this again still on the same branch and not added to the main branch yet. So I cleared this, and now since we had been doing the git push origin main, now what we need to do is we need to push this to the remote and create the same branch on our remote as well. So if we look at our remote repository, you'll see that this branch does not exist yet. But because we've created it in our local repository, what we can do is we can say git push -u origin. And now instead of main, we say 5 sum by astro feet. And once we do this, it will say this branch is set up to track the origin branch. And now if we look at our GitHub, so again, the GitHub repository is intelligent enough to know that a new branch has been pushed. It's also giving me an option to open a pull request directly. But let me reload this. And if I look at the branches here, it gives me the new branch as well. So when I go to the main branch and I say, when I look at this branch and it shows me what's going on, it shows me that, oh, it is one commit ahead of the main branch. And this is the commit that we made where it is adding all the functionality that we've added to our main branch. So that's the comparison. But again, this is still existing on a different branch where this is another version of that code. And now what we can do is we can go to a pull request and we can open a pull request to merge that change in. So this is kind of the overall workflow. Now I'll just show you quickly. Basically, again, I say I have added this feature. I have this in a separate branch, and now I want this to be a part of my main code base. I also want to say that it fixes the issue 5. So if I say fixes #5, what this will do is once this pull request is merged, it will also automatically close this issue. So there are certain keywords in GitHub. So fixes, closes, both of those work to close issues automatically upon merge. So, and also again, when we do a hash, we can see a reference to all the other things. So we can see that if I mention 2, that would mention the second pull request. So let's say which is the open one? Let's see. Oh, it's the first one. So let's add a test reference for the first pull request, and let's say it fixes the issue 5, and I create this pull request. So now, like we saw, Dependabot created that change for us. Now we have created a change, and again, this can be between multiple people, and we say that it's fixing this issue. So now if we go to that issue, it will mention that, okay, I've linked a pull request that will close this issue, and it shows the pull request. So it shows the references that we're making. And if we go to say the first pull request, it will show that, oh, that I mentioned this pull request in this other pull request again. So again, whenever you make a reference, that also shows up in these sort of interfaces, in the pull requests and the issues interfaces, and they also sort of keep track of each other. Similarly, I can look at the files changed like I did before, where if someone wants to add a review, they can submit a review here and request changes or approve changes or just make a comment and tell us what is sort of their review of my changes. Now, I'm happy with these changes. So what I'll do is, again, this is our main, which hasn't been updated yet. I'll just look at the pull request and I see this pull request is opened. All the changes look good. And I can just do a squash and merge. So once I do a confirm squash and merge, we'll see that there is a new commit, but this commit has been added through a pull request. So this is not me directly pushing to main, where we can also see in the bracket, it says #6, which it does not say for the initial commits, which are just pushed to main. But if I look at #6, it takes me to the pull request where I've added that change and also pushes that change into the main branch. Now, these are the different ways that I can sort of add changes to a project or collaborate. And essentially, again, as we were talking about, this is usually a very popular workflow when you're working on collaborative projects, when you're looking at projects which have multiple people working on them. So, as a last thing, let's go to our local project and say we switch to main again. So I'll delete the results for now. Now, what we can see is that we have the main branch, but we do not have the updated pull request here, the updated changes here. So once we do a get pull, it brings those new changes from the remote repository. And again, as we were looking at GitHub, it shows us all the interfaces of what the changes are and updates our local branch as well. So at this point, both our local project and our remote instance are up to date, are in sync. Both the main branches are in sync, definitely. And again, I can now go to this branch, or I can just view all branches. And since I see that this branch has already had a pull request merged, I can just delete this branch safely now. And that also sort of helps me keep the project neat and tidy. And I do not want all the branches to add up in my main branch, in the list of branches. So here again, we have a workflow of how you sort of make changes to GitHub or how you add or request sort of certain features, make pull requests. We can look at a community example of this. So if we, for example, go to Pandas, so yeah, they have like 3,000 issues, and you can see that they've labeled their issues, and they have lots of sort of different ways to categorize issues. So for example, that is an issue for docs where they want to change documentation, but then they've also labeled them as, okay, this is a bug, or this is a performance issue, or this is something for API design. For example, if we look at this issue, it talks about, again, what are the suggested fixes, what is the issue. Then there might be some discussion where different people are talking about uh, their perception of the issue or whatever thoughts they have. And similarly, okay, through here, we can just go through pull request. So here is a pull request that has been opened to fix this issue. Now, if we go to that link pull request, we can see that this again is similar where they have a change of file where it shows the code base. And there's a discussion where someone has made a review where this developer says that this looks like a bug and this should not be used like this. And they've reviewed it. And now they are essentially probably waiting for the original author to make changes, and then they'll review it again and see if they'll approve it. So this is again the way it actually works in projects. Now, if we look at, say, a closed pull request, someone made a pull request, and here we can see that someone approved the changes, they merged it, and now it's gone into Pandas dev main branch, and that this code is a part of the main code base. But again, all these pull requests that are open right now, they are essentially requesting changes, but they've not been merged. But yeah, that is somewhat a quick overall run through of pull requests and issues and how collaborative sort of uh, workflows work. Workflows are used in software projects and coding projects or while sort of working with version control. Uh, yeah, can I show the contents of my new summary table results file? Okay, I actually was too quick and deleted it, I think, but I think I can switch branches and get to the results. Let's see. Oh no, those were not committed, so maybe switching won't help. Yeah. I can generate those again. Okay. Is it this file that you were referring to, Alex?
Yeah, I got the same, but I was just interested as to why it doesn't seem to have any information about like any other columns.
Right.
Perhaps that relates to late further material.
Yeah, I mean, I was not sort of checking the code logic or like defining the code logic as I was going. This was more of the example point of, okay, this is how it can be done. But if folks are interested, this is the example that is used in episode 8 of the material. I pasted that in the chat as well. But yeah, I think that brings us to the close of this lesson and to the close of the course. So I'll give everyone a couple of minutes and yeah, I'll wait for questions. So what questions do people have? I know that that was a lot, I think, like of following through, but again, it's more meant to be as a reference. But please do ask questions if you have any. And again, if people feel that they might not have any questions or comments, or yeah, have been able to sort of get a better understanding of the workflows that are used in Git and GitHub, if you'd like to give a clean tech, that would also be helpful. And give everyone a couple of minutes. And if folks can then fill in the minute card feedback for the day, and just post that in the chat. And we have the main post workshop survey that I'll also post. And that's a post workshop survey. We'll also send this out through email after the course, and yeah, send the recordings from the days as well. But please fill in both those feedbacks. That would be very, very helpful for us. The minute card feedback is just the quick feedback from today, and the post workshop survey is the overall feedback for this week for the 4 days. And just a general note, and again, I know that there was a lot of information shared. It's sometimes difficult to sort of just yeah think of all the feedback or think of all the things that you've looked at. But yeah, as we said, if something particularly stood out to you, or if something particularly you felt could be improved or you did not understand, all of those things would be very helpful for us to know because, again, as we iterate through this course, we try to improve it or we try to adapt it on how it is delivered, on how people feel when it is delivered. And again, I think the best sort of people to tell us is all of you and the audience who's going through the course. and learning it with fresh eyes. But yeah, I think that's mostly it for me. I think we might have a couple of wrap-up slides. Let's have a look. But yeah, I think that's just a summary of what we did this week, where when we look at good software development principles, uh, we looked at engineering practices and we ended up with software in a much better shape than when we started, where initially it was a random file that was in a zip, was incomplete, was in an email. We unarchived the file, we added it to version control, and then added the sort of structure to it, the version control, the environments, looked at testing, looked at continuous integration, got into a remote, and then again looked at how do we interact with that sort of code base, how do we document it, how do we publish it, or say get a DOI for. And yeah, I think this quote is very fitting, where it's the best time to plant a tree was 20 years ago, and the second best is now, which I think, yeah, I think Alex might have put that, but it is very accurate in terms of code. I feel like it's always just it can be overwhelming to think of just, oh, how many changes you can make or how much sort of something needs improvement or the little things you can do. But I think even sort of the little steps of just adding version control to an old code base or adding a README to something that might help you or others is very helpful. But yeah, I hope this was helpful to everyone, and I hope yeah, you're able to implement these practices in your day to day.